Hi, my name is Vlad, and a couple of years ago I started a channel called Dev Inside You to improve the developer inside you and me. My channel is all about professional software development, and since I have been working with Scala almost exclusively since 2010, the majority of my content is related to Scala in one way or the other. Now, I have been following Traversy Media since Brad had around 30k subs, which feels like it was yesterday, by the way, and so when the opportunity presented itself to expose Scala to so many of you, I had to take it. Today we're going to attempt something that has never been done before. Firstly, since I imagine most of you being JavaScript savvy, we're going to add some JS flavor to this Scala crash course. And secondly, we're going to make it a bit more functional than usual. Now, even if you have never heard of Scala, upon searching for it on the internet, I'm sure that the first piece of information that you will find is that Scala is a blend of object-oriented and functional programming. And for historical reasons, even though FP is older than OO, OO has been dominating the industry for many years, and it arguably still does. Since for a crash course to be successful, it at least needs to be familiar, most crash courses out there focus on the OO side of things. There is a certain fear that FP would scare people off. And so believe me when I say this, Scala is one of the hardest languages to make a crash course about. I'm all about inspiring the new generation of software professionals, and so I made a conscious decision to believe in you. I'm convinced that if you pay attention, you won't get lost. And so we're doing FP today. That said, we're not gonna jump into the deep end of the pool. We're going to play with some simple things like immutability. We're going to use a little bit of recursion, and we're going to learn about very powerful combinators defined on collections instead of using loops and stuff. So here's the plan. First, there will be a couple of slides. I have just 3 of them. They explain why you should be interested in learning Scala, why right now is the best time to do it, and also what Scala actually is. Then we're going to see how to install it on your machine, and since this crash course is JS flavored, we're going to be using VS Code today. And there is a language server protocol integration, so we're going to get auto-completion, inline errors, and all the cool things like debugging. And afterwards, we're going to have the typical components of a crash course. We're going to talk about types, literals, keywords, if expressions, loops, functions, function currying, classes, case classes, algebraic data types. Don't get scared only because this word is unfamiliar. And we're even going to discuss Scala's most controversial features like implicits. Since this is a crash course, we'll go through everything very quickly, so don't get concerned if you don't understand everything the first time you watch it. The goal is for you to just get a feeling of the language and its place in the world. Alright, I hope you brought some popcorn because it's about to go down. To the slides. Before we even see what Scala is, let's talk about why you might be interested in learning it. So here are some reasons that come to mind. Scala is one of the few, if not the only, academic languages widely adopted in the industry, and so you don't need to worry about it being just a toy. Being research-driven makes it very regular and thus powerful. You look at things and they just make sense, because they're based on solid theoretical foundations and not on arbitrary decisions made by language creators. That said, there's still plenty of room for arbitrary decisions, so don't expect miracles. It's still just a programming language, and it's still written by humans. Another benefit of it being a research-driven language is that you have a front row seat to the bleeding edge of technology. Chances are that there are things in Scala that you have never seen before in any other language. Interestingly enough, chances are also that you will recognize many things since many programming languages borrow from each other. Scala compiles to Java bytecode, and thus A, runs on the Java virtual machine, one of the most advanced runtimes out there, and it also runs on the Android runtime, which is similar for the most part. And B, the entire JVM ecosystem can be used. Libraries from Java, Kotlin, Clojure, anything that compiles to bytecode. Scala also transpiles, if required of course, directly to JavaScript, which allows you to have a 100% Scala stack, which means your JSON is shared, your routes are shared, your validation logic is shared, etc., etc. We're not going to discuss this part of Scala further in this crash course though, but it is very cool. We have some nice wrappers for React and friends. Check out scala-js.org for more info. Don't forget the hyphen. I do it all the time and it leads to nowhere. Now, Scala can also compile directly to native code. This part is not production ready yet though, but it is in a mature enough state to actually write some non-mission critical native apps. Scala is a general purpose programming language that can be used for anything your heart desires, from thousands of microservices to tiny CLI applications and even shell scripts. It is a first citizen in the GraalVM ecosystem, which among other things allows you to take some bytecode which would normally run on the JVM and compile it to native code, thus making it launch like a rocket and consume less resources. Being compiled to native code, whether with Scala Native or via GraalVM, also allows you to write native iOS apps. But I'll be honest, as of right now, that's a bit of of uncharted territory. Now, even though Scala is a general purpose programming language, I should probably mention that, at least for now, it found its niche in either web backends or anything related to data, like data mining, machine learning, AI, etc. The next point will be a surprise for most people. Contrary to popular belief, it is one of the purest 100% object-oriented languages out there. Even though Scala is most famous for its FP features, you can safely learn it while concentrating on the familiar features first, like mutable variables, arrays, and other mutable collections, inheritance, and side-effecting constructs like loops. And once you get comfortable, you can gradually discover the functional world. So come to the dark side, we have cookies. I should probably talk about this point a bit more. Scala attracts a lot of FP enthusiasts because, contrary to a language like Haskell, Scala is widely adopted in the industry, meaning that there are more than enough Scala jobs out there, which we will talk about in the next point. Now, FP, being the most exciting side of Scala, is responsible for this illusion around Scala that Scala is an FP language. It is not. It's just that the majority of the content produced about Scala is about FP and category theory. However, it is actually not so easy to find a Scala job which really does pure FP. Not because they don't want to, it's just that the entire industry is learning and it takes time to get there. What I'm saying is that the majority of the industry is silently and happily programming in OO, whereas the FP minority is being very vocal about the FP benefits, and so now everyone is convinced that Scala is a pure FP language, and all Scala developers read academic papers in their free time, which couldn't be further from the truth. Yet another thing that I should probably mention is that Scala, being a multi-paradigm language, is a double-edged sword. You might be programming in Scala for a couple of years, then switch companies and end up on the other end of the pool and have a hard time recognizing the language you thought you knew. Let's talk about jobs now. Even though there are more than enough Scala jobs out there, the amount of jobs is being dwarfed by the giants like Java and JavaScript, which are not related to each other, just FYI. There's a bit of history there where JavaScript adopted Java's name back when Java was super popular, and JavaScript had a similar mantra of runs in every browser, but as already mentioned, apart from the name, there is virtually no relation. Now, even though a small number of jobs can mean that it is hard to find a job, it's not all that bad. The thing is that there aren't that many Scala developers either, and since Scala is widely adopted in the industry, the Scala developers are hard in demand, which is one of the reasons why Scala is the highest paid developer job worldwide according to a Stack Overflow 2020 survey. The link to this survey is going to be down in the description. Now, some folks have a problem with people getting into technology for money alone, but I'm not one of them. There will be no gatekeeping here. I do have a fair warning though. Scala tends to be very corruptive. Chances are you'll fall in love and maybe even discover a true passion for programming. You don't have to believe me, just please don't say that I didn't warn you. Scala has extremely concise syntax. The reduction of lines of code is sometimes 10x compared to most mainstream languages. Less code means less bugs, however it sometimes comes at a price of readability. Sometimes it's just too concise. Scala has an extraordinarily powerful static type system, meaning less bugs, but sometimes at the cost of compilation speed. This point heavily relies on your experience and discipline though. It is for you to decide to what degree to use the type system. Your code is not going to magically contain less bugs if you're being complacent. Another thing you should probably know about is that most types are inferred by the compiler for you, so there are very few places where type declarations are mandatory. That said, the more experience you gain, the more you will want to specify the types to help the compiler out and improve readability in the process. Let's not forget, Scala is a lot of fun, but don't take my word for it and take it for a spin yourself. Now that we talked about why, let's talk about why now is the best time to get into Scala. And for this, we need to understand Scala's versioning scheme. When I got introduced to Scala in the early 2010, the version was 2.7.x, semantic versioning, so X is a bug fix release. 2.8 came out the same year, and after that, a new version came out every 1.5 years or so. There was 2.9, 2.10, 2.11, 2.12, and now we're at 2.13. 2.13.3 to be more precise. In the end of 2020, or probably rather in the beginning of 2021, because software estimations, am I right? A new Scala version will come out, but this time the version is not going to be 2.14. It is going to be 3. Scala 3 is a major release. It is based on a brand new calculus that took over 7 years to develop. The compiler was rewritten from scratch. Many esoteric features were dropped and many new ones were introduced, and yet 99% of the Scala 2 code that you will learn about today will magically work exactly the same in Scala 3. There is a ton of work being done to avoid the Python 2 versus Python 3 fiasco, and Scala's powerful static type system and the fact that the Scala 2 libraries can be used from Scala 3 and vice versa help a lot. There is already a milestone 1 release and it looks very promising. I played with it already and I can't wait for it to be released. Scala 3 presents a unique opportunity for a new wave of Scala developers. This is the perfect time to get into Scala. Seriously, the timing for this crash course couldn't be better. Now, as already mentioned, we will be covering Scala 2 today, but I will occasionally hint at some syntactic goodies that will be available in Scala 3. Alright, let's finally talk about what Scala actually is, and luckily we already covered a couple of points. Now, even though it is a 100% pure object-oriented language, more about that in the upcoming points, Scala heavily leans towards FP. You might be wondering, what does this even mean, and also how can this be? See, there are no statements in the language. Even something as simple as println hello world, by the way, println is an equivalent of console log in JS, is not a statement. It is an expression instead, meaning that even side-effecting expressions like this one produce a value. This fact alone encourages your programs heavily to be written in the FP style, where the entire program, no matter how big, is one gigantic expression composed out of tiny other expressions. We won't go that far today though, we'll stick to the basics. And so, instead of fighting about whether Scala is OO or FP, it seems much more fruitful to look at it as a 100% expression-oriented language. Let's talk about what this means. If there are no statements, then you will less likely write your programs in an imperative style where you say do this and then do that. Expression composition will look differently, and so there is less need for semicolons. Again, we're not gonna do any of that today. Today we will write simple things like println hello world and underneath println something else. But we still won't need semicolons. The compiler will infer the semicolons for us, but we can still use them if we wanted to put those printlns into the same line, which nobody does, by the way. In fact, compared to JavaScript, there's no debate in Scala whether to use semicolons or not. We just never do. Now, every expression is guaranteed to produce a value, with the exception of, well, actual exceptions. If they don't produce values, they terminate the program in the middle of execution, which is why in 100% pure FP applications, exceptions are not used, or at least they're not thrown. Now, apart from this caveat, if every expression produces a value and the language is statically typed, then every value needs a type. So even something like println hello world has a type of unit. Now, types can have 0 or more values. For instance, when an exception is thrown, the type that is produced is called nothing, meaning it has 0 possible values. A statement like println hello world, which has a type of unit, has only one possible value, which is also why it's called unit. The way you summon this value is by using empty parens. And so if you were to println hello world, we would first see the hello world printed out, but then we would also see empty parens printed out. We'll demonstrate this a bit later. Now, if you compare this to a language like Java, which does have statements, a system out println hello world doesn't produce a value, which is why it doesn't need a type, which is why void in Java is a specially dedicated keyword. I know that this sounds far-fetched, but very subtle details like this make FP hotter. For instance, FP heavily uses parametric polymorphism, also known as generics. Let's say for a list of ints, a list of strings, or a list of dogs. The same thing for JavaScript's promises. You can have a promise of int, promise of string, promise of dog. Now ask yourself, how can you have a promise of void if void is not a type? That thing that goes inside of these parentheses has to be a type. Also, if there are no statements, only expressions, and we're thus forced to always produce values, we are forced to program in such a way that we would never jump out of some random block of code. So there is no goto, there is no break, there is no continue, and even though we do have the return keyword, it is considered an anti-pattern to use it. The last line of a function or a method, which is just a function defined on an object, is returned for you, which also means that we don't need extra constructs like, for instance, the ternary operator present in some languages. Our if statements are actually expressions, so the last line of every branch is returned. This also means that since we're encouraged to write expressions instead of statements, we rarely need to denote a lexical scope. Very often we can leave out unnecessary parens. For instance, you only need to use curly braces in a branch of an if expression if it contains multiple lines. Otherwise, you can leave them out. This is improved even further in Scala 3, which supports Python-like indentation-based syntax. Now, since Scala is a 100% pure OO language and every expression has a value, every value is an object, even functions themselves. There are some optimizations which compile simple things like integers to primitive JVM types, but unless you are concerned with performance, you as a programmer never have to deal with this distinction directly. Also, since everything is an object, you can call methods on everything. And guess what? There are no operators in the language. Every operator you see is just a method call, so 1 plus 2 is just infix notation for the method plus defined on int, and the 2 is just an argument. Scala is a very regular language, which makes it scalable, which means that when you define your own constructs, the syntax is so powerful that it will feel like a construct built into the language, so you can grow the language. For instance, you're not limited to alphanumeric identifiers only, which is a double-edged sword, by the way, because you can create libraries that use too many of these syntactic tricks to the point that Scala becomes unrecognizable, so care must be taken to not overuse every little feature. And just FYI, Scala actually stands for a scalable language. Now, we could spend hours on slides alone, but it's time to actually start hacking over here. So let's install it. These days, the fastest way to get started with Scala is by using a tool called Coursier, which is French for courier. Why French? Well, because the developer is French. Now, Coursier started out as a pure Scala artifact fetcher. It used to be able to go to Maven and just download Java archives for you. These days, however, it's becoming its own package manager. Now, for historical reasons, I have always been a Windows user. That said, since around 2013, anything remotely related to software I had installed inside of virtual machines, and recently I switched to the Windows subsystem for Linux. I don't even have Git installed on Windows. The only things I do have installed are the Windows terminal and VS Code. Since I want to demonstrate how fast you can set up your development environment for Scala, we're actually going to create a brand new, entirely empty Windows subsystem for Linux instance and set it up in there. So I'm just going to open the Windows Store. I'm going to click on search. I'm going to type in WSL, press enter, wait a couple of seconds, and we're going to go with Ubuntu 2004 LTS. Now there's a tiny bug in the store that the button says launch, but I actually don't have it installed. In fact, let me show this to you. If I open Windows Terminal and I type in WSL-L-V, you're going to see that I have two of them. The one called Dev Inside is the one that I usually use when I record my videos, which I would use today, but I want to use an empty one today. And another one called Space, which stands for Workspace. This is the one that I use to prepare videos like this one. So I'm going to exit and I'm going to click on launch over here. It's actually not launch, it's actually install. It says installing. This may take a few minutes, but it should actually take just a couple of seconds because it's cached. Let's wait. There we go. So I'm going to call my user Vlad, some password again, and there we go. We're inside. I'm actually going to close this. I'm going to close this. I'm going to go back to Windows Terminal, and I'm going to do the same thing as we did before, like this. As you can see, there's a new one, Ubuntu 2004. So now I'm going to go inside of D. So they're actually called distributions, but I'm used to call them instances. All right. So we're going to do Ubuntu 20.04, and now we're inside. All right, let's switch to my home folder. Let's press Ctrl L so that I have a clear screen. Now, for good measure, let's at least update it. Update and sudo apt y full upgrade. All right. While it does that, it should take only 30 seconds or so. I'm going to go to another virtual desktops over here where I already have a prepared Chrome instance. This is the website of Coursier, and we're at /docs/CLI installation. Now I'm going to show you the installation in Linux, but the installation in Mac OS and in Windows is pretty similar. You just download this tiny binary, right? So in this particular case, we're going to download the one for Linux. You can also download the one for Mac OS or use Homebrew to do the same thing, and the same thing for Windows. You download the one for Windows, you make it executable, and you run it. Now, as already mentioned, Coursier is slowly becoming a package manager of its own, so you can do things like CS, and by the way, it's a convention to call it CS. You can call it however you want. So you can do something like CS install some Scala tool or CS uninstall some Scala tool. And recently it received a command called setup, so we can just do CS setup and it will install everything that we need. Let me minimize that, go back, it should be done. Yep, it's done. All right, so all we need to do, I'm in my home folder, which doesn't have any files in there. So I'm just going to do curl or CURL, which is a tool to send HTTP requests. And I'm going to go to https://git.io. Now, git.io is a URL shortener, and so we need to ask curl to follow redirects. So we need to include this -l flag. All right, then we're going to go to Coursier CLI Linux, and it's going to be a file, so we're going to output it into a file, and we're going to call it CS. Okay, now it's 52 megs, but I have a really large connection, so it should be really fast. If I type it correctly, it should actually be called Coursier -CLI Linux, like this. Okay, so as already mentioned, it's 52 megs, but I have a fast connection, so it should finish in just a couple of seconds. All right, so come on. ls-hl. As you can see, it's 52 megs, the only thing that I have in this directory. Okay, now all we need to do is to make it executable. So we're just going to do a change mode +X, and we're going to do CS. Let's do ls-hl. As you can see, it's now green and it has now the X flag, which means that it is now executable. Now, since it's not on the path, we actually need to do /CS, and all we need to do is to do setup like this. It says that there is no JVM found. Should we try to install one? Well, yes, please. It's an empty machine, so we need a JVM. Now, the entire industry is currently still using Java 8, even though there is already Java probably 15 or something. Recently, Java switched to a 6-month schedule. However, every couple of years there is a long-term support version, and 8 is one of the long-term support versions. Okay, and there are a couple of vendors for the Java virtual machine, and the one that we're using is adopt OpenJDK, which is a very good one. Now, the way Java works is that you need to have a Java underscore home environment variable, and so Coursier is now asking me if we should update the my dot profile, so it will just export this variable for me, and I'm gonna say yes. All right. Now it also warns me that that it changed the profile, and therefore it recommends to close the terminal once the setup is done. Okay. It also puts this folder on the path as well. Right. Path has yet another environment variable, and so we're going to say yes. And this is the folder where Coursier is going to install all the other tools. So as of right now, it is actually installing up a couple of tools, and among them is actually Coursier itself. So after it finishes installing itself, we will actually be able to remove this tiny file. We're not going to need it. Okay. Now it is installing Ammonite. Ammonite is a Scala REPL, a read eval print loop. So you can go in there and you can imagine it being just a nice calculator. Okay, now it installs CS, which is Coursier. It is also going to stay installed Coursier, so you can do both CS and Coursier. Let's see what the next thing is going to be. Then it installs Scala, which is also a REPL, and Ammonite is a slightly better REPL. It has syntax highlighting, it has multi-line editing, and so on. It installs the Scala compiler, but we're not going to use the Scala compiler directly. We're going to use SBT, which is a Scala build tool, and it will compile the Scala code for us. And it also installs Scala FMT, which is a it's a linter, it's a formatter. So now if I cat into my profile, we're going to see that it inserted these couple of lines. So it exported Java home, so my JVM is now over there, and it exported this path variable. So if we were to go into local share Coursier bin, we would see that it installed all of these tools. Okay, like this. All right, so all we need to do, remember the installer told us that we need to exit first, so we're going to do this. So I'm back into Windows, I'm going to go back into Ubuntu, and now if I say Java version, it should work. Okay, now if I do something like in any folder that I am, I can just launch, for example, Ammonite, which is this Scala REPL, and we can start writing Scala 1 + 2, print line hello world, things like this. All right, let's exit over here. Let's do Scala as well. This is the native Scala REPL. Works in a similar way, but there's less syntax highlighting. 1 + 2, print line, hello world. All right. Okay, so one other thing that we're going to do is we're going to install another tool called Jitterate. I'm going to do ACS install Jitterate. Now, Jitterate is a template manager. It's sort of like what is it? React Create App or something like this. Okay, so it could pull templates from GitHub and create projects for you. Now, these days, Jitterate is also built into SBT. Okay, so the first thing that we're going to do is we're actually going to use one of those templates. We're going to use mine. So what I'm going to do is I'm going to make a directory. I'm going to call it dev. We're going to switch into dev, and obviously there is nothing in there. And so what I'm going to do is I'm going to do SBT new. And now I'm going to say dev inside you /scala seed.g8. Okay, so this is my GitHub, so it's going to go to github.com/dev inside you. Inside of it, it's going to find a repository called scalaseed.g8, and SBT behind the scenes, it will use Jitterate to create this template. Okay, now the first time you're starting SBT, it's actually going to download half of the internet, so it's going to take some time. So what I'm going to do is I'm going to minimize this terminal. I'm going to bring it to the right. While it does that, I'm going to start an entire new instance. I'm going to put it on the left. I'm going to connect to the same instance. I'm going to go to my home folder. I'm going to go into the dev folder. And in the meantime, we're going to do a very similar thing. So instead of doing SBT new, okay, it doesn't remember my history. Okay, so instead of doing all of that, we're going to do G8, right? So similar to this one, a G8 dev inside you /scala3 seed .g8, and I'm simply doing this to show you that jitterate is faster. In fact, you don't actually need to do .g8 for jitterate. You could have left it out. See, it already finished. Okay, so I'm gonna call this one playground 3, and I'm gonna use com.traversy media, which is a common convention for Java packages and Scala packages to use the reverse domain of your company. Okay, and for a package, I'm going to use exactly the same thing. Enter. And there we go. Over here, we have a folder now, playground 3. Now we're going to wait for SBT to finish. I'm simply going to cut it out from the video. All right, so it took a couple of minutes, and really, if it takes longer for you, don't worry about it. Just let it finish, don't kill the process. As you can see, one of the last line was resolve in jitterate, and we are presented with exactly the same prompt as over here. So this one is going to be called playground. Okay, we're going to use the same organization, Traversy media, package the same way. All right, cool. So now over here we have two folders. One is going to use Scala 2 and the other one is going to use Scala 3. There is also another folder called target. This is what SBT usually generates for itself. So in this particular case, we can simply remove it. Okay, but for real projects, inside of the target folder, this is where your compiled code is going to reside. All right, so what we're going to do now is we're going to go into playground over here, and we're going to go into playground 3 over here. Okay, now usually most CLI tools, they're not interactive. You just say, some tool space do something like we did with G8 with a GA, install something. SBT is designed to be interactive. So basically you go into the folder within your project, you just start it. And then the first time you start it, it's going to load a couple of things, so it's going to take some time. The next time is going to be a little bit faster, but I'll have to be honest, it's not going to be like too fast anyway, right? So it has a bunch of stuff to load. It has a JVM to load and so on, okay? And then essentially you sit in there all day until your memory runs out. As of right now, it says non-compiled module, compiler bridge 212. So we're going to use Scala 213 today. However, SBT itself is written in Scala, and this is the version that was used for it. So it sort of compiles itself. In fact, the SBT that coursier installed for us was actually not SBT, it was the SBT launcher. So the launcher downloaded the appropriate SBT version for us. Okay, now this is my template, and therefore it has a bunch of aliases, but we're not going to use any of my aliases today. The commands that I'm going to show you today are going to be the regular built-in ones. Okay, so for example, we can say compile, and because it's compiling a Scala 213 code base for the first time, it will present us with a similar thing like over here. It's going to say non-compiled module, compiler bridge 213. Okay, this is only the first time it does things. Like all the other things are going to be faster. In fact, everything that we're going to do today for the first time is going to take more time. Okay, now we're going to start working with a couple of commands here, but in the meantime, I'm also going to start SBT over here. As you can see, it will start a little bit faster. Okay, so now the code is compiled, so we can, for example, run it. Now, because it already compiled, it ran really fast. Now, if we type in clean, that it will go to this target folder that we talked about a couple of minutes ago, and it will remove everything. So now, if we do something like run, it will notice like, hey, I don't have anything compiled, and so it compiled this one Scala source code. Okay, and as you can see, like the second time it compiled it, even though this is not some sort of incremental compilation, it actually was really fast because SBT caches a lot of things. Okay, so another thing that you can do is compile the tests. Okay, but usually you don't need to compile the test, because when you want to run the tests, the SBT will be smart enough to figure out that it needs to compile stuff. So if I clean the whole thing, I type in test, it will figure out, oh, it needs to compile the production code, it needs to compile the tests in order to run them. Everything in here is going to be the same. I'm just going to type in CA, which as you can see stands for compile all. Behind the scenes, it will just do test compile. It will know that the tests depend on the production code, so it will simply compile everything that we need. Okay, now also I want to show you that formatting is built into SBT, so we can do Scala FMT all, for example, and it will format all the files in there. There are two production code, there are two test files, and there's one regular file. This is enough for now, so we're actually going to close both of them. I'm just going to press Ctrl D, and as you can see, we're back in the regular directory. I'm actually going to type in exit because I don't need two terminals anymore. Okay, in fact, I probably don't even need this one. Okay, but still, I'm going to press Ctrl L. Even though I'm inside SBT, it still understands the same command to clear everything. I'm going to do Ctrl D to exit, so we're again inside of my folder, and all I'm going to do is I'm going to say code dot, and this will launch VS Code through WSL because this is a new virtual machine I keep calling it virtual machine, but it's actually just a distribution. VS Code will sort of split itself, install the server version on WSL. If you're not using WSL, you don't need to worry about anything over here, anything that I'm saying right now. Now, I was already prepared for this, and so VS Code remembered that I had a project that was called main, which is why I'd open it like this. And it seems to be completely empty. This is probably some VS Code issue. I'm just going to close it. I'm just going to open it again. Code dot. Let's see. Yeah, so now it loaded properly. Okay, so the first thing that we're going to do is we're going to install a couple of extensions. So I'm gonna do this. I'm gonna go to extensions. We need only one extension for Scala. However, we're also going to install a couple of extensions that are simply useful for Visual Studio Code in general. Now I have a bunch of them installed, but the way WSL works is that none of them are installed actually inside of Ubuntu. So I need to pick the ones that I need to be installed there and installed. One is called remote. Again, this has nothing to do with Scala. I'm sorry, not remote. It's called a reload. All it will do is it will. I'm going to click install in WSL. All it will do is it will put a tiny reload button over here, which is super useful. You just click it and VS Code reloads. Okay. Another one that we're going to install again has nothing to do with Scala. It's called error lens, and all it will do is it will display error messages and warnings more prominently. There will be more in my face. Another thing that I should probably mention is that I'm using Fiora code, and Fiora code has ligatures. So for example, if I do double equal sign, it actually looks like this. It is awesome for production applications, but for recording tutorials, it might be confusing. And so I'm going to install another plugin that will disable the ligature once I'm at the same line. Okay, so the extension is called disable ligatures. However, VS Code recently actually changed something, and it actually doesn't work in the latest version of VS Code, so I actually had to downgrade my version of VS Code. All right, cool. So one of the last things that we need to install is actually the only extension that we need for Scala called metals. And by the way, most people who develop Scala, they either use the IntelliJ IDEA or any IDE, any editor that metals supports, right? Metals, the LS in metals stands for language server. So it works with all the editors like Sublime, Vim, Emacs, and all of the others. Okay, so I'm going to say install. It is going to take just a couple of seconds to install, and all of the extensions that we installed, all of them told us that we need to reload VS Code. So I'm going to reload it. All right. As you can see, if I put my cursor over here on this line, the ligature was disabled. As you can see, I put my cursor in there on the same line, and the ligature is disabled, which is super convenient. This is the metals extension, and it installs itself and all of the things. It noticed that this is a Scala project, so we're going to say import build. Here are a couple of commands that you can do with metals. You can restart the server, cascade compile, and all these things. Like usually you don't need to touch this. Like usually all of the things are happening behind the scenes for you. Now, while it does that, let me actually minimize this. Let me actually go back to the code so that I can walk you through a couple of things that we have over here. We actually don't need this. All right, now this is a minimal Hello World application. We pretty much have only one .scala files over here. All the Scala code lives in .scala files, and it gets compiled into target Scala 213 classes. As you can see, like this one source file was compiled into multiple classes. Like this is the JVM bytecode. Okay, by the way, we actually don't need this anymore. Now, sometimes it says something like this: failed to connect to the build server, no functionality will work. You can simply restart Visual Studio Code, or you can go over here again into metals and you can say, connect to build server. As you can see, it's connected to the build server over here. So everything sort of fixed itself. Now it's downloading the presentation compiler. All right, there we go. Now things like formatting are already built in, so you just save the file and it's been formatted for you. Okay, now as you can see, everything worked out just fine. So we actually have buttons for running. Like if I click around over here, VS Code will actually run it. As you can see, we have just a bunch of hyphens over here. So if I do this, then you're going to see that this is actually what's being printed out. We can also debug stuff. Actually, debugging is useless if I don't put a breakpoint. We can click on debug over here. Okay, so now it's stopped over there. We can, step into, for example, now we're somewhere in the middle. Notice that we're landed in predev.scala, and the way methods works is that, because VS Code is just an editor, it basically sees that you need the Scala file, so it takes the source code, it puts it into this read-only file so that you can view it, okay? But if we close it and we actually minimize this, we actually don't need it. All right, now there are many files over here. We actually don't need most of them. All right, we're actually gonna stick to only this one directory. We're actually gonna still just have a couple of files over here. Now if I go to example suite over here, we can actually also run the test just by clicking on test, and it will run the tests that are in here. Why is it still debugging? Did I forget to press stop? Example suite, let's just test it. There we go. We can see that the Hello World suite worked out just fine. A couple of things that you should probably know about the metals extension. So if we go into our source code, so we can click over here and we can say new Scala file. And one of the files that we can create is a Scala worksheet. Okay, we got to call it main as well. It's been created over here, main.worksheet.sc, and you can sort of treat it as a Scala REPL. So you can do, for example, 1 plus 2. You can print line hello world, and after it finishes evaluating for the first time, we're actually going to see the output over here. We can hover over here over a side effecting thing, and we're going to see hello world over here, but we're not going to use worksheets today. Okay, I'm going to close it, and I'm in fact going to delete it. Delete permanently, like this. All right. Now, a couple of things that you should probably know. In fact, let's in the meantime actually run a terminal inside of VS Code. Let's actually run SBT. Okay, so a couple of things that you should probably know. Scala, compared to a language like Java, does not have this constraint that your classes have to be called exactly like the class file, like the files. Also, we don't have this constraint that your classes have to be, that there can only be one class in a file. It's in fact, like very often you will want to have many classes in the same file. Okay, now we're going to go through everything step by step, but before we do this, let me actually throw you in the water a little bit. Okay, before I do that, let me actually do, so remember I said like you can do like something like compile. Okay, now the way SBT works is that if you prepend commands with a tilde like this, then what it will do is it will compile and it will actually observe the source code changes. Okay, so every time, actually let me do this. Every time I change something, for example, I say hi, okay, it will notice that the file changed and it will recompile the code. And we can do this with any command. So for example, we can just pressing enter goes out. So we can do, for example, run. Okay, and so now I can go, let me actually have less hyphens. So I can do this, and now it noticed that something changed, it reran everything. Let me actually switch it back to hello world. Now we're going to do everything step by step, but before we do this, allow me just to explain what you're already seeing over here. Now, packages are simply namespaces, and the way the syntax works, this is just a syntactic sugar. By the way, Scala has so much syntactic sugar, it's very easy to get diabetes. Okay, so this is syntactic sugar simply for this, for a curly brace over here, curly brace over here, and a curly brace over here, and a curly brace over here. So basically what it says is that this entire code is in this namespace. Okay, so for example, over here I can print out main, which is an object, but I can also print out playground.main, right? Because playground is just a namespace, and I can also do com.traversymedia.playgroundmain. Notice that I cannot leave out the com like this because of the way it's written over here. Let me actually revert all of that stuff. We're going to use this syntax for now. By the way, this red line comes from this extension called error lens. Like usually this is how the error would be reported, but error lens also writes it over here. All right, you can use it with any language. Absolutely any language. Okay, it just draws the errors and warnings much better. Now, Scala is an object-oriented language, so we have classes. So at any point in time, you can do something like class dog. Okay, but sometimes you only need one instance of this class dog, and so Scala has a built-in support for that. So this is what we see over here. We see object main. This is a singleton object, and yeah, that's all I have to say about it. Now, because it's an object-oriented language, it has inheritance and subtype polymorphism. So what we're doing here is we're extending app, and app is a trait. Traits are similar to Java interfaces, but they can actually contain implementations. And what it does is it allows you to have some code in the body of this object, which is like a class, but it's like a class and instantiation of the class at the same time. Okay, and now in the body of this object, which is by the way also the constructor of this object, this code will simply run as part of the main method. Okay, so we're not going to use it today actually, so I'm going to remove extends app, and now SBT will tell me that there is no main method to run. So we can actually go and introduce a main method, and I'm going to explain the syntax a bit later, but essentially you say def, you call it somehow, you open the params for the arguments list, and we're going to call it args, which is a typical convention. We're going to say array of strings. This is how we have array. This is how parametric polymorphism is done. Generics, we use notice that we use the rectangular parens, which means that when we're accessing values of arrays, we cannot use the rectangular parens. We're going to use the regular parentheses for this. Okay, this is going to be the parameter name. Then there is going to be a column. This is going to be the type for the parameter. This is one of the few places in Scala where you actually have to specify the type. Then we're going to specify the return type of the entire method, which is going to be a unit, and this is going to be an equal sign, curly braces, closing curly braces over here. Okay, let's remove this empty line, and now everything recognized again that this is a regular main method, similar to what you would see in Java. Now this part is probably the most confusing one, but once we're going to start doing things, step by step, it's actually going to be super clear. The first thing that we're going to discuss are going to be the comments. The way you comment out a line is by using // and VS Code has shortcuts for it. If you just do Control/, it will just comment out the entire line like this. As you can see, hello world is not being printed out. If you want to comment out just a part of the line, then you would do /* and then close it with a */. Like for example, I don't know, let's say we wanted to comment out this, and I can do Control-Shift and / and it will put these stars for me. As you can see, it's commented out. Now this code obviously is not going to compile. Okay, now Scala, same as Java, also has a concept of Javadoc, and the way you declare Javadoc, like the regular comment was like this, okay, but for the Javadoc you would actually use an extra star and put the stuff in here. Okay, so I actually prepared something for you. I'm just going to paste it over here and it will be formatted for me. Okay, so now a Javadoc is sort of like a markup language. So if we hover over main, we will actually see exactly what I just written. This is the main entry point of the program. When the program starts, the main method will be executed, and these are the parameters. All of this was generated by this Javadoc, and Javadoc is a common convention for libraries. So if I remove this and I hover over, for example, something like printline, you're going to see that there's Javadoc. If I were to jump in there, you would see a similar thing written over here. My comments are red. Usually they have a very light color like gray, but I rarely write comments, and so when I do see a comment, it better be important. So I want it to be in my face as much as possible, which is why in all of my themes and all of my color schemes, I actually make my comments red. All right, let's play with the args a little bit. Okay, so we can do printline args, which is just an array. Now, this is the typical, default rendering of Java arrays. And by the way, as you can see, that this is an array of Java long string. So this is actually a Java type over here. Okay, so in order to better render it, we're just going to call the method called makeString, and we're going to pass in \n to simply separate the parameters. Okay, so these are the arguments that are being passed to your application. And the way you can do this is by doing run, and then you can do like first, second, third, for example, and we should see them being printed out over here. Okay, makeString is also overloaded. There is another version that wants to do something at the start, and then the separator, and then something in the end. So what we're going to do is I'm going to press enter over here. I'm going to say that the start is going to be array like this, comma, the next argument is going to be the separator, which is going to be like this, comma, and we're going to do and, which is going to be like this. Okay, so now if I'm going to run it, we're going to see that this is how it is rendered. Now let's actually start doing things step by step. Like until now, everything was a little bit ad hoc. Now the first thing that we're going to learn about are the keywords, and there are a couple of keywords in the Scala language similar to JavaScript. So JavaScript, for example, has lat constant function. Scala has val. It has var, it has def, it has lazy val, and it has type. Okay, so now we're going to go through them. Okay, the very first one is a val, and it is similar to constants in JavaScript, and therefore I'm going to name it const. Okay, I hope it's not too confusing. So we're going to do val const is 1337. Okay, now this is not just syntax. Scala is not just fancy syntax. In most languages, you cannot do something like this. This is an expression, and therefore it can be a bit more involved. So for example, I'm going to open a curly brace over here, and I'm going to close it over here. Now, by the way, I have a formatter, and it notices things like this and says, hey, you have only one thing in there, so you don't need the curly braces. So if I save this, it will actually remove them for me. But I'm actually going to need them. So I want to write print line I'm going to bind const to 1337. Now, because I have multiple things in this scope, I actually need the curly braces, and so my formatter, my prettier, so to say, it does not remove the curly braces. And as a reminder, the last thing in the scope is being returned and assigned to const. And so if we go and do a print line const, like this, we're going to see 1337 over here. Okay, I'm actually going to do this again, and it's going to be more important for the next ones that we're going to talk about. Okay, so let me actually duplicate this line, and beneath I'm going to copy this. Well, I'm actually going to copy all of this. I'm going to paste it over here, and the next keyword is going to be var, and var is similar to lat, not to var in JavaScript. Scala is not a scripting language. We don't have any necessity for complicated things like hoisting. Okay, so var is like lat, and over here it's still going to say I'm going to bind lat to 1337. We're going to use lat over here and lat over here, and you will see that it behaves exactly the same. Okay, like this, like this. However, var actually allows you to mutate things. Okay, so what we can do is over here we can do lat, without again, lat is not a keyword. I just named this variable lat. I hope that this is not too confusing. Okay, so I'm going to do lat equals, and over here exactly the same deal. So we can have some scope. We can say over here I'm going to assign 1338 to lat. Okay, and I'm actually going to do lat plus 1 like this. Okay, so we're going to do this, and as you can see, it did this already. And over here we're just going to do print line lat like this, and we see it being printed out. Okay, the next thing that we're going to do is we're going to talk about the fact that Scala really encourages you to program in a functional way, and because of this it does not have things like plus equals 1, right? So instead of this, I'm sorry, plus plus, right? So something like lat plus plus that usually would work in some other languages, it actually doesn't work over here. So you actually have to do this, okay? Or you can actually do lat plus equals 1 like this, tiny shortcut, okay? But essentially it really encourages you to program based on expressions, and it will become more and more evident the more we move along. Okay, let me actually remove this, and also remove that. Okay, so we have a val and we have var. The next one is going to be def, and let me actually copy this, and I'm going to paste it over here. So we're going to call it def, and def is similar to functions in JavaScript. So I'm going to call it function. Again, don't get confused, like this is just a name, this is just a name, and this is just a name. These are not keywords in Scala. Okay, so over here we're going to say I'm going to bind function to 1337. However, but I will recalculate it every time. Okay, so the first thing that we're going to do is we're actually going to do a function over here, and I'm actually going to comment it out. Okay, so we have a def over here, but we're not seeing any of this because it's like a function. If we don't call it, we actually don't see this stuff. So I'm going to run it once, I'm going to run it twice. Okay, so now you see this entire code twice. Okay, before we were not seeing like this line twice. Okay, because this scope was already evaluated, this side effect already happened, this value has been memoized over here. Same thing for a val, not for the def. Okay, the next one that we're going to see is actually going to be a mix of def and a val, and it's called a lazy val. Okay, so I'm going to go over here, I'm going to call it lazy val. Well, I'm going to use the keyword lazy val. I'm going to call it mix, and I'm going to say I'm going to bind mix to 1337, but only on demand, which means when it's used. Okay, so now if I have mix over here, and I'm actually going to comment this out, we're not seeing any output, between these hyphens and between these hyphens. The first time we run it, we actually see this. Okay, so for defs, we were seeing it every time. For lazy vals, we're seeing it only once, but only the first time we're actually going to use it. So to recap, let me remove all of that stuff. Okay, we have val, which is like a const 1337. We have let, which is like a variable. See, I'm like, I'm used to typing var. Okay, lat is going to be 1337. Def function is going to be 1337. Lazy val mix is going to be 1337. And by the way, this is also where this equals sign comes from. As you can see, this is a def main. This is a def function. Then there are parameters, and if there are no parameters, you can just leave this out. Then over here there is a return type. Over here there is no return type. We're going to talk about this in just a couple of seconds. As you can see, the return type is inferred for you. It's integer in all of these cases. And then you have the equals sign. Okay, now we have all of them. It's just sometimes if you just do this, if you don't have like these print lines that I had before, then at the usage side, you don't always see the difference, right? You have no idea, how these values were calculated. Now let's talk about functions and also methods. Now usually methods in object-oriented languages are simply functions that are defined inside of some classes or some objects. However, in Scala the distinction is a little bit more blurry because Scala is a very regular language and it allows you to have depths inside of any other scopes. For example, over here we have a val const. We can go inside, create the scope again. Okay, remember where the last thing is going to be returned, and inside of it we can have a def. I'm going to call it method, but technically it's not a method. Okay, I'm going to do 1337 and I'm simply going to return its value like this. Okay, so over here nothing is going to change because you can nest so many things. The distinction between methods and functions is not so clear in Scala. And in general, you can do all of these: val, var, def, lazy vals, and this was, by the way, lazy vals and types. And I'm going to show you types in just a couple of seconds. You can declare all of them only inside of the top level definitions. The top level definitions are class, object, and trait. Okay, everything else you have to declare inside. And this is actually different in Scala 3. In fact, this is something that I forgot to do. I'm actually going to go over here into my terminal and I'm going to open the Playground 3 also with VS Code, right? So remember, this is Scala 3. I'm actually going to put it on a different workspace over here. It says the same thing, import build. So I'm going to do this. It has the same main method. Okay, it looks very similar. It has, it has this Python-based indentation syntax, which is optional. You can still have like regular opening curly brace over here and closing curly brace over here. We're going to spend most of the time in the Scala 2 part, but occasionally I will jump to this one and we're going to do some Scala 3 stuff as well. Let me actually save the file. Let me actually go back over here, go back to VS Code like this. Okay, so this is Scala 2, and sometimes I will jump to Scala 3 and show you a couple of things. Okay, maybe by the way, in the meantime, I can actually also open the terminal, move panel to the right, start SBT over here, give it maybe a little bit more space. I should probably also do just like 50 hyphens. Okay, so as you can see, the next time you start SBT, it takes just a couple of seconds. Okay, so I'm gonna do run over here as well. Okay, and I believe, by the way, in the other Scala version, we're actually running with first, second, and third. We can actually just do, just do the regular run. Okay, now what I wanted to show you is that over here, as a top level definition, you cannot have a def, right? So you cannot do this. Okay, however, in Scala 3 you can. So I'm actually going to cut it out. I'm going to go over here and I'm going to put it over here. And it works just fine. Okay, the same thing was all the others, everything that I have shown you: val, var, lazy val, and type. Okay, but in Scala 2 you're being limited to the top level objects being objects, classes, and traits, and we're going to have examples of this later. All right, now functions and methods, obviously they can have parameter lists, and sometimes it happens that the parameter list can be empty. So if we do this, now what is happening right now is that we're seeing an error over here. And the first thing that I'm going to show you is that in our build file, which is a configuration file for SBT, I have a compiler flag. As you can see, it will be passed to the Scala C, which is the Scala compiler, which makes all warnings being errors, right? So all the warnings are being converted to errors. In Scala, we like to program in a very type-safe and very restrictive way. We want bad things to be like as bad as possible so that we can see them right away. So I'm actually going to comment this out. Notice that the build tool will notice right away. It will reload everything and will now produce a warning instead of the error. However, for VS Code to work normally, we will actually import the changes. While it does that, I'm actually going to go and do exactly the same thing over here. I'm going to go to the build and I'm going to disable this flag. I should not forget to remove this comma. Exactly the same thing is going to happen. SBT will notice, it will reload, rerun the code, and now we're going to also import the changes. While it does that, I'm going to close this file, go back over here. I'm going to close this file, everything finished, and now we're seeing this warning. This is also the warning over here. You can also go over here and press F8 and you should see the entire warning like this. You can also go over here, this is VS Code, right? So the same as you do with JavaScript, there's a language server protocol integration, so you're going to see your output over there. Okay, Now, for a very long time, there was a niche use case in Scala that you can declare a function with an empty parameter list, but you could call it without specifying a parameter list at all. So over here, I could specify the empty params and then the warning will go away. But if I forget it, it will actually do this. Now, the warning actually says that this auto application is deprecated and we should supply the empty argument list explicitly to invoke method function or remove the empty argument list from its definition. Okay, and in Scala 3, an unapplied method like this will be ATA-expanded into a function. And I'm actually going to show this later to you, what ATA expansion even is. For now, we're simply going to do this. Now, as you can see in the warning, the Java methods are exempt. Now, this whole thing goes by the name of the uniform access principle, and it is actually very, very pleasant. So for methods like Java, for example, if we go over here and we do println hello world, and if we want to figure out the length, we can just start typing length, and over here, as you can see in the string, length is actually a method. So in Java, you would be forced to have these empty params. However, in Scala, I can actually leave them out. Okay, and for example, for something like array, like our arguments, I'm going to do length, and arguments length is actually well, if I jump in there, we're going to see, okay, in this particular case, it's also a def, but if this was like a clean, pure Java array, you would see that length inside of array is simply a field. Okay, so over here it's a method, over here it's a field, but you as a programmer don't need to worry about it. Just leave the empty params out. Now, if you wanted to talk about the arguments for functions, we need to talk about types first. So let me actually remove this. Now, in Scala, the types are inferred. So let's actually remove this nonsense. Let's do 1337. Okay, the types are inferred. So if I hover over here, you're going to see that these are integers. However, you can always specify the types if you want to, and sometimes you have to. And the way you do this is you go after the name and you do colon, and then you specify the type. And the type is integer. Notice that it's a capital I, not the small I like in most languages. So as you can see, the compiler already knew that the type for this was actually an integer, which in Scala is a 32-bit signed integer. However, in some places it cannot know this. For example, if this function actually had arguments and the syntax is the same as over here, right? So let's call it P1, for example, it's going to be an integer, and P2 is going to be an integer. Okay, then and now we actually have to specify them. So let's do 1 and 2. And by the way, Scala's functions, they have name parameters, so we can do like P1 over here or P2 over here if we wanted to. Let's actually remove this. And by the way, Scala also has a default argument. So for example, if we do over here a 4, then we can just remove this and it's going to be 4. We're not using any of them over there, so we don't see it right now. So let's do like 1 and 2. Okay, now Scala has a so-called local type inference. So without knowing what the type of P1 is, it would not know that we can do something like P1 times. Okay, right? Without knowing that this is an integer, it would not be able to figure out that this method, and by the way, it's a method, it's just an awesome syntax for methods called the infix notation. So Scala compiler would not know that where to look for this method for without knowing that this is actually an integer. Okay, so if we do P1 times 1337 divided by P2, okay, again, as a reminder, this is just syntax. Okay, so this is just a dot. Okay, this is the name of the method. Okay, this is just an argument. Okay, now whatever comes out, we're gonna do dot again, like this is just a method. Okay, and this is just the argument. Okay, so this is exactly the same code. This is just a notation. So in Scala, when you also declare functions, you're not limited to alphanumeric characters. For example, you can go and you can define a function, and we're going to call it times, right? So we're going to have a first argument, we're going to have the second argument, and by the way, the return types of functions, unless they are recursive, can also be inferred for you. So over here, we're just simply going to do equals, and we're not going to specify the type. Okay, so over here we're going to do first times second, for example. And by the way, this is also a common mistake. Never forget the equal sign. Okay, so now if we wanted to call this function, we would do times, regular function call syntax, we would do like something like times 2, 4, and let's also, print line the whole thing. Print line is something like console log, and maybe we should do, let's surround it real quick with this. Okay, as you can see here, it's the 8. Okay, now let me remove all of that. Okay, now in general, the alphanumeric characters are, you're not restricted to alphanumeric characters. However, you cannot start your functions with letters. Okay, so if I put a 3 over here, then, as you can see already, we're seeing that this is not a valid syntax, and it's also not going to be valid syntax in Scala 3. Okay, let me do this and let me do this. Okay, it's a convention to call all of your val, vars, defs, and lazy vals with a smaller letter and use camel case for this. However, it is also a convention to call all your types, object classes, and traits with a capital letter. Okay. Also, so let me actually show this to you. So we can do def my multiplication is better than yours. Okay, so as before, we're going to do first int, second int. This time we're actually going to specify the return type. We're going to do first time second, and over here we're going to do print line my multiplication is better than yours first second. And as you can see, this is well, I actually need to specify 1 and 2, and as you can see, like, this is just a name. I can call it whatever I want. Okay. By the way, in Scala, if you need to have some really weird name for some really weird reason, you can do backquotes, and inside of it you can do spaces and, you know, minus signs and whatever you want. You can actually start it with a letter. You can do 3 space minus, you know, blah, and it will actually work, right? So Scala will figure out how to call this method if it is surrounded with backquotes. You can also use like regular words in backquotes like blah, okay, and then over here you don't need to use backquotes when you call them. Okay, like this. All right, let me remove this. There we go. As already mentioned in the first part of this crash course, you're encouraged to actually specify the types. Like me personally, every time I have a def, I always specify all the types, even the return type. And it is also a convention to specify the types for all of your public members. And by the way, the default visibility in Scala is public, so therefore we don't need to do public def main or something over here. And as a reminder, Scala is a pure object-oriented language, so we don't have anything like static methods. Instead, we have these objects, and inside of them we're declaring the methods. Now let's talk about types, and one of the ways to look at types is by looking at them as sets of values. And so I will introduce the types to you in the order of their of the amount of their values. Okay, so the least interesting type is actually called nothing. So nothing, it's written like this, you know, the capital nothing. This is just a name. Okay, so nothing has no values. Like nothing, I cannot write anything over here that would actually produce this value. The only way I can sort of produce a value out of nothing is by throwing an exception. Throw a new exception. By the way, notice that we don't need to use like empty parents. As you can see, the code compiled over here. Okay, but at runtime it actually threw an exception. Okay, now this is the least exciting code, but essentially the point is that everything will stop. Like this will become unreachable code, and we're not going to see it here, and we're not seeing this print line, we're not seeing anything like this. Okay, now, and the next one is going to be unit. This is the one that we're seeing over here. We're going to call it unit1, unit, and sort of like the literal for the unit is like this. Okay, so we can, for example, print it out, unit1. It's being printed out over here. I accidentally removed this guy. There we go. Okay, another way to do this is by doing this. I'm going to call unit2, and I'm going to use curly braces. Okay, now this is just a convenience syntax. Well, what is happening inside it is actually that it just returns the unit like this. In fact, if I save this, Scala FMT will probably remove this. So I'm going to save this without formatting like this. Okay, so yeah, this is how unit works, and we're going to encounter unit a couple more times. Okay, now contrary to popular belief, Scala actually has nulls. So I'm going to do danger null. So null is another type. It has only one value, which is null. So nothing had 0 values. Unit has only 1 value. Null also has only 1 value. Let's print it out. Danger. All right. The next one is going to be Booleans. So let's actually have a bit more space like this. So we're going to do val yes, which is a Boolean. We're going to do true. By the way, Scala is a statically typed language, so we don't have anything like true C values or false C values. You know, if we have if expressions or while loops or whatever, we actually need to use Booleans in there. Okay, let's print line yes. Let's do print line yes. Let's do val no. Boolean is going to be false. Print line no. There we go. True false. Not a big deal. Let's talk about some numeric types. Okay, so we're going to do byte min. So one of the smallest numeric types is byte, and we can do byte dot min value. Okay, so byte is an object like similar to main. Okay, remember as we were doing, for example, over here we can do like val x equals 1337, and now over here we can access it by doing print line main dot x. This is the same thing that is happening over here. It's just that what's inside is a constant, and there is a convention to call constants with a capital letter. It is actually not just a convention; it is actually necessary for some parts of the language. Okay, let me remove this. Let me remove that. Okay, so this is how we can get the minimal value. Print line byte min like this, and we can do byte max, which is also byte. We're going to do byte dot max value like this, and we're going to do print line byte max like this. Okay, so this is the smallest one. This is the biggest one. Now, in order to save some time, let me actually copy paste something from my script. Let me insert it over here. So as you can see over here, we're starting with bytes, then we have shorts over here, then we have ints over here, then we have longs, they're over here, then we have the floating point numbers over here, and we have the double, also floating point numbers with more precision. Let me remove all of that, and I'm going to take this opportunity to introduce you to types. So Scala has an ability to introduce type aliases. So we can have a type alias like this, and it's going to be an alias for integers. And so now we can do my favorite number, which is going to be of type n, that again can be inferred, but over here we're just going to specify my favorite number like this. Works out like a charm. Over here we're going to do val n colon n is going to be 1337, and I'm doing this to show you that the names for the types and the names for the values, they live in their own namespaces, sort of like in their own dimensions. And this is done for use cases like when you have a class dog. Okay, so I'm going to have a class dog. This class actually defines a type for you as well, which is called dog. Okay, so we can do type d equals dog. Okay, so as you can see, like this is a type, like everything that is on the right hand side of the equal sign, it has to be a type. Okay, so for a class there is also a type defined dog. This, for this reason they have to live in separate namespaces. All right, let's talk about literals. We have already seen a couple for units and null, and the literals for things like shorts, bytes, and integers are very straightforward. So I'm only going to show you the notation that is slightly different, and this is going to be the hexadecimal notation. Okay, so you can do a1 equals 0x and then a hexadecimal number. For example, f is a 15. So if I print line a1, we're going to see 15. It used to be possible to also have octal numbers, like for example 09, but these days it's not possible anymore. Okay, so let's return it to 0xf. Okay, it is also possible, I believe actually since Scala 2.13, to to have underscores in your number just for visibility. If it's a really long number like 1 2 3 4 5 6, let's print it out, then you can just go and put an underscore over here. It's not going to change the actual number, just for your visibility. Okay, now let me actually print out let's print out a long max value over here, and I'm actually going to grab it. Okay, Control Shift C, and I'm going to go over here. I'm going to say val a3 equals this number. And as you can see, the default type that it infers for this is going to be integer, and so it says that this number is too large. So we need to help it and to say that this is a long. However, just specifying the type is not enough. This is simply too big for a literal. Okay, and the way you do this is by specifying either a small l or a capital L. Now, a small l, it looks like the letter like the digit 1, and therefore my formatter will notice this and it will rewrite this to the capital L for me. Okay, and if I save without formatting, I believe it's Control K, Control Shift S, then we're going to see a warning that that it's preferred to use the capital letter. Okay, so this is going to be a3. Let me duplicate this couple of lines, a couple of times. So this is going to be a4. A4 is going to be float. I'm going to specify the small f, but it's actually going to be rewritten by the formatter to a capital F, I believe. No? Oh no, the other way around. So the big F will be written to a small one. Now we're going to have, whoops, let me remove this. Let me do this. So it's going to be a5, a6, a7. I'm not sure if we're going to need so many. Okay, so this is going to be a D for doubles. It's going to be written to a small one. This is actually enough. So let's go and print them out. Print line a3. Duplicate the line a couple of times, a3, a4, a5, like this. We can also use the scientific notation. So for example, a6 is going to be -3.4028235 E38. Okay, and now if you print out A6, it's going to look like this. The next thing that we're going to talk about is going to be characters and strings. And the most important distinction that you need to know about them compared to JavaScript is that you cannot freely decide between single quotes and double quotes. Single quotes are always reserved for characters. Double quotes are always reserved for strings. Or we even have triple quotes for strings, and we're going to get to that. Okay, so let's print out the character A, and let's print out the capital A. Let's print out the \n, which is a line break, so we see like an empty line over here. And let's also print line a \u to 500. Okay, so this is, by the way, this is this fancy hyphen that I have been using to 500. Okay, so we can also just copy this and use it as a character over here. Now this notation is the Unicode notation, so you just do \u and then the hexadecimal number. All right, so let me duplicate this, put it over here. We can do exactly the same thing with strings. Okay, as a reminder, these are going to be strings that contain just a single letter. Okay, but they're strings now. It's a completely different type. Okay, so the next thing that we're going to do is we're going to play around with strings more. So I'm going to duplicate this, and I'm going to go over here. I'm going to print line. I'm going to do hello plus space plus world, like this. Okay, we see the hello world, not a big deal. The next thing that we're going to do is I'm always going to be like duplicate these lines. All right, so I'm going to copy paste this. Okay, so now we're seeing hello world twice. Okay, so over here we're going to mix strings, right? So \n is just a regular character like O or L or anything like this. But as you can see, it's not rendered as you might want it to be rendered, because we have a space over here. Now we have a notion of raw strings. So in fact, I'm actually going to copy this line, and this way I can always like paste it, and I can go over here and I can do print line. And now we're going to do triple quotes, right? So we have 3 quotes. I'm going to press enter over here. So we're going to do hello, and we're going to do world over here. I'm going to join lines like this. Okay, now as you can see, it's not rendered as you might have wanted, right? Because it took like all of these spaces over here. Now there is a way to solve this. Let me do one more of these, and let's do a print line again. And in this particular case, so in fact, I'm actually going to clone this one like this. Okay, so you can use like an arbitrary character over here and then call a method called strip margin and just pass in this character. Again, like, you need to pass in the character. If you do like something like this, even though it's a valid string, this is not what strip margin wants. Strip margin actually wants a string. Okay, so if you jump in there, I'm sorry, it wants a character, right? It wants a character. Okay, let's go back. Let's close this one. Let's switch it back to a regular character like this, and as you can see right now it is inlined normally. Okay, now the default character for this is a pipe, so you can go over here, you can use a pipe over here, and if you're using a pipe, then you don't need to do dot strip margin. I'm sorry, you need to do dot strip margin, but you don't need to specify the argument, right? So it's overloaded, so you can go in there and you can see now we're calling this one. It's simply called strip margin with this character. Not a big deal. Now the next thing that we're going to talk about is going to be string interpolation. So if we do my favorite number equals 1337, okay, then over here we can do a print line, and we're going to use an s, letter s, and only then we're going to open the quotes. Okay, as you can see, the syntax highlighting already recognize that this is going to be string interpolation. So we're going to say this is my favorite number, and we're going to do dollar my favorite number. Okay, now similar to all of the other rules in Scala, if it's one expression, then we don't need curly braces over there. However, if you wanted to do something like let me duplicate this line. Okay, if you wanted to say something like this is my favorite number plus 2, okay, then we would need this to be an expression, and because it's an expression, we need the curly braces. Okay, so we're going to do plus 2 over here. Okay, so my favorite number plus 2 is now an expression. Okay, and therefore we need these curly braces. All right, that's too much space. Like this should be enough. All right, cool. Let's continue. We have printf, but we also have another interpolator for strings. So over here we're using s, but we can also use f. So what I'm going to do is I'm going to clone these lines. Okay, now over here I'm going to use f. Okay, and now what we're going to do is over here when we say my favorite number plus 2, after this expression, let me actually create more space. Okay, we're going to use this printf syntax. So for example, we're going to say that this is going to be just a digit. Okay, and then it's printed out, exactly the same way as before. However, what we can also do is we can let me just copy this and paste this. Okay, and now instead of %d, we're going to do %8.2f. Okay, now 8 is going to make sure that everything from here to here is 8 characters, right? So this is 8 characters, right? So it's basically like padding. So we can do something like maybe even 20. Okay, as you can see, it's just being padded. Okay, let me revert it back to 8. Okay, the .2 is the number of characters, number of digits after the dot. Okay, and the f is going to say that this is going to be a floating point. Okay, now I actually rarely use this, but what is important to know is that this string f interpolation, it is actually happening at runtime. For example, if I go over here and I replace this d with a k, you're going to see that this code is not even going to compile. As you can see, we're seeing the error illegal conversion character k, which is super awesome. It is super safe. Scala developers, we really like very safe code. Okay, one of the last interpolations that I'm going to show you is this weird thing that if we have like this hello world, for example, over here, and we're going to go duplicate this line, and we're going to have this hello world over here. Now, if we put a \n over here, it's going to be simply inserted, right? So it's not going to be interpreted because this is a raw string. However, as soon as we switch this to interpolation, even though we're not actually using any variables, as soon as it is switched to interpolation, this will not be escaped anymore. And there is a way to solve this situation simply by using yet another interpolator, and this one is called raw. Okay, so the difference between raw strings and raw is that it does not interpret the escaped characters, and at the same time you can still use string interpolation. Okay, so you can do my favorite number. Okay, so it will still be inserted over here. By the way, Scala is a very scalable language, so you can actually define your own interpolators. For example, it is very typical for database drivers or GraphQL drivers to define their own something like SQL, something like this, and then maybe at compile time the syntax of your SQL query would be actually checked for you, which is super convenient. All right, so let me remove all of that and let's finish the conversation about types by talking about if expressions. Okay, as a reminder, they're expressions. Okay, so if we do something like if true and true or something like this, then we're going to return good, and otherwise we're going to return bad, then this is an expression, right? So it has a value, so you can just simply do val result equals like this, and you can print out the result, result like this. Okay, and again, we don't have any truecy or falsy value, so you cannot like put a 1 over here or a 0 over here. It actually needs to be a real Boolean. If you wanted to have multiple statements or multiple expressions over here, you would actually need the curly braces. You would need to do something like this: print line I'm in good. Okay, and then if I type correctly, it's going to be print line I'm in good. By the way, the inferred type over here is string. Okay, so I'm in good, and if it is false, then this is not going to be printed out. Okay, great. So you can also, if I remove these, Scala FMT should probably, okay, it doesn't, it did not remove them for me. Okay, so you can also write them in one line, so we don't have a use case for ternary operators. Okay, now the reason I'm showing you this is that if you remove else, right, so in most languages the else case is actually optional, then we're going to see that the result type is being inferred to any. Okay, and as you can see, what is being returned is unit. So what is happening behind the scenes is this else unit, or else curly braces and unit, something like this. Okay, and so the returned the inferred type is any, which sits at the top of Scala's hierarchy, right? So all the types are subtypes of the any type. If we switch it to true, we should see good, but again the type is any, so you cannot do something like reverse. Okay. Great, let's remove this. Okay, another thing that I'm going to show you is that we also have a type between any and some very specific types. So for example, if instead of string we're going to put a 5 over here, then the inferred type is actually going to be any val. Now for a very long time you could not create your own any vals. These days you can, but it's just an optimization and we're not going to talk about this. Okay, so we have a bunch of primitive types. I believe it's 8. The unit is one of them. Then they all extend any val, and any val extends any. Then on the right hand side we have any ref, which is like an any reference type, right? So any class you declare is going to automatically extend any ref. For example, if we go back to using a string over here, and we're going to use some other class object, like something like main over here, then we're going to see that the inferred type is actually object. Technically, it's any ref, but any ref is just an alias for Javalang object. Another thing that I want to show you is that nothing is a subtype of every other type. And so if we go over here and throw an exception, throw a new exception. Okay, by the way, again, like if you don't need the params, you don't need to specify them. Okay, then the inferred type is going to be, let's see, it is going to be string, right? So now we can actually do result.reverse. Okay, it actually works just fine. But if we do false, the code is not going to get there anyway, right? And therefore it's semantically sound. Okay, let's have a slightly larger example for the if expressions. So we're going to say wanna watch a movie or go for ice cream, like this, and we're going to say movie is going to be a Boolean. We're going to say ice cream is going to be a Boolean as well. Okay, the entire method is going to return a string, and we're going to have an equal sign. And because it's going to be one expression, we don't need the curly braces. So we're going to say if movie and ice cream, then return the string awesome. Otherwise, else if movie or ice cream, then just return still cool. It's fine if we do just one of them, and otherwise let's do boring. Okay, now let's actually call this print line wanna watch a movie. We're gonna use movie equals false, ice cream equals false, like this. We're gonna duplicate this line 4 times. So we're gonna have false, 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 true. Let me actually create more space, like this. False, 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 true, true, false, and true, true, true over here. All right, there we go. Boring, still cool, and awesome. By the way, it's a convention usually to call Booleans like this, like is movie, but for this particular case, I did not do this. Okay, what some people prefer to do is to also join the lines over here, like this, and like this, and like this. It looks a little bit shorter. It's kind of cool. Let me actually revert this. And so what I'm going to do over here is I'm going to have this, and I'm going to type in, I'm going to say print line, I'm going to have a string, and as the value of the string, I'm just going to put this in, like this. And over here, I'm going to do the same thing, like this, like that. The last thing is always returned. I'm simply going to do print line, and I'm going to say that we're in this particular case, like that. Over here, I'm also going to do this, okay, and I'm going to do that, and I'm just going to say print line else, and I'm just going to have print line like this, and like that. Let's have space here, and space here. Okay, so that we see this, and I'm simply doing this to show you that we don't actually need this in Scala 3. So if I were to copy this and I would paste it into Scala 3, which would work exactly the same in Scala 3, however, I configured it in such a way that it will actually rewrite this code to the Scala 3 syntax. So if I'm right, then these curly braces should simply disappear. Hold on, let me indent it like this. Like this. Yeah, as you can see, like exactly the same code works in Scala 3. First of all, it compiles, and second of all, it works exactly the same. So if I copy these guys, I go over here, I print them out. I need to be very careful with indentation because formatting does not work that well yet. Hold on. Okay, this is actually one of the very nice things that you have. Like, as you can see, accidentally, I put them into the same indentation, and we're not in Python here. We have a very strong compiler, so it thinks that we're returning this thing from this method, okay? But the return type of print line is a unit, but over here we said that it's going to be a string, which is also one of the benefits of actually specifying the types. This way the compiler will have your back even more, okay? So now it thinks that we're returning this unit from this method. All we need to do is I actually need to move it one layer to the left, and as you can see, it behaves exactly the same. Now again, this syntax in Scala 3 is not mandatory. You can still use curly braces, and also you can close the scopes if you want. So for example, you can go over here and you can say, hey, I'm going to end the this method like this, right? If it helps your readability, and I believe you might even be able to end the if like this. Okay, and I also want to show you is that if we let's actually remove these guys. So if you wanted to have only one thing in there, oh, by the way, another thing that I forgot to show you is that in Scala 3 you actually don't need the params over here, right? So you can just do this, and this. Okay, and because you don't need the parens, when you're joining the lines, it actually needs to be able to distinguish this from this. And so as you can see, the error message says that it expected a then, so you need to do then. Okay, so you can do a then, join the lines, and join the lines. So you can also write it like this. It behaves exactly the same as before. Let's go back to Scala 2. Now, I don't want to confuse you too much with with Scala 2 and Scala 3 syntax. So for the major part in this crash course, we're going to stay in Scala 2. I'm only going to show you a couple of really cool things in Scala 3. Okay, now let's talk about a couple of Boolean operations. So we're going to do print line 1 through 37 equals 1 through 37. Again, I'm using ligatures. As soon as I leave this line, it's going to look like this. Okay, so let's have a bit more space over here. Yes, they are really equal. So let's also do not equals. So it's going to be the exclamation mark and the equal sign. If I leave this, it's going to look like this. Okay, so let's actually duplicate this line a couple of times. Okay, so this is going to be smaller, same as in most languages, bigger, smaller or equals, which looks amazing in Fiora code like this, greater or equals, which again looks amazing in Fiora code. Let's run all of them. True, false, 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 true, true. All right, so let's have a bit more like this. So what we're going to do is we're going to do print line test equals test, and also not equals test. Now in Java, this would be a referential equality, and you would need to make sure that when you're dealing with reference types and not with the primitive types, that you would call actually equals over here, right? And in Scala, you can do the same thing. As a reminder, this is just a call to dot equals, okay? But in Scala, you actually don't need to, because in Scala, the regular this symbol actually just delegates to equals. Okay, now at least in Scala 2, these comparisons, they're not super type safe. And by the way, you can also check for reference equality as well. We have special methods like EQ and NE. Okay, so these ones are reference equality, but you actually never need them in in the regular applications. Now, Scala is compatible to Java. This is one of the major selling points of Scala, that a lot of things are work like very, very similarly. And so we have equality defined on any, and therefore, unfortunately, you can actually do this. You can do test equals 1, and it will compile. Now, obviously, at runtime, it will still do the run thing, but we would have preferred it to not even compile. In fact, if we turn them around, if we do 1 equals test, then we're gonna at least have a warning. And this is one of those things that I will actually show you in Scala 3, because in Scala 3 the situation got better. We don't need any of that stuff. By the way, over here you see that the main got too long, so we can also do end main like this. All right, let's remove all of that. Okay, so I'm going to paste them over here like this, like this, like this. Okay, so in Scala 3, actually none of this code is going to compile, which is awesome. So as already mentioned, Scala 3 is safer, more beginner friendly, and so on. All right, let's go back over here. The only thing that is left to do in terms of the operators, and by the way, I'm simply going to remove this one because I don't want, well, actually, I'm just going to comment this out because I don't like this warning. All right, so the only one that is left is the Boolean operators. So we can do not true, we can do print line true or false, and we can do print line true and false. And by the way, as in most languages, they have the same precedence. So if you have true or false and true and false, and all of these things, make sure to use the parens to have more control over the precedence. All right, let's do some simple recursions. So what we're going to do is we're going to have a function. We're going to call it loop, and it's going to have a parameter which we're going to call ACC, which stands for accumulator, and we're going to do int over here because we have to specify the type. Okay, now because it's going to be a recursive function, the compiler is actually going to force us to specify the return type. So I'm going to do it right away. The return type is going to be unit. Okay, so all it will do is it will say if ACC is smaller than 10, then just print it out. Okay, and we need curly braces because we're going to have two things over here. And by the way, notice that the formatting is ruined, but Scala FMT is going to fix it for me once I finish typing. Okay, now over here we're going to call ourselves like this, and again, like the last time, the last line of the if is going to be returned, the last line of the last time of the def is going to be returned. So we can simply write it like this. As you can see, the formatting was fixed for us, so now we can actually call loop like this, and we need to specify ACC, and we're going to go with 0, for example. Okay, we can actually have a default argument 0 over here, and now we actually don't need to specify it. Okay, so now we have a simple loop that goes from 0 to 9. Now Scala has a concept of tail recursion, which means that if the recursive call is in the tail position, meaning it's the last thing that is happening in every branch, which it is right now, then the Scala compiler can and probably will rewrite it to a regular loop, and so it's going to be way more performant. There's also an annotation that you can attach to your methods or your values that will make sure to tell you when you think that your recursive call is in the tail position, but it is not. Okay, so we can attach it by simply doing annotation dot tail rec. Now annotation like this, it lives in the Scala object, and the Scala objects are being always imported for you, but I always prefer to do actually Scala.annotation tailrec. Okay, so if this was not a tail call, if the function actually had to come back and do something, like for example add 1, then it would not be okay, so in this particular case it actually does that. Let's actually do print line hi. Okay, then it will say could not optimize tail rec annotated method loop. It contained a recursive call which was not in the tail position, right? So this is not the last thing, so we cannot always go forward. At some point we need to go back and do this print line. Okay, so amazing. All right, now we're going to throw it out, and we're going to replace it with a simple var. I'm actually not going to throw it out. I'm simply not going to call it. So we're going to replace it with a simple variable and a while loop. So we're going to have ACC equals 0, right? This particular case, we don't need to specify the type. It will be inferred for us. So what we're going to do is we're going to have a while loop, same as in most languages, ACC equals 10, and then we're going to do print line ACC, and we're going to do ACC plus equals 1. As a reminder, we don't have a plus equals 1. As you can see, it runs the same way. And by the way, if it's one expression, same deal as always. If we don't do the print line, for example, then it actually works without the curly braces. Okay, but I actually want to have the print line. And by the way, it's sort of like as you can see, I have like an empty line. It's sort of like a habit of mine. Like I like to, like the return line, the last line that is being returned, I always like to have an empty line before it. Okay, it just helps a little bit visually. Now what's interesting is that as I already mentioned, everything is an expression. So this entire while loop is actually can be assigned to some variable, right? As you can see, the type of it is actually unit. It is actually more interesting if we convert it into a def, and we kind of make it a function. Okay, and at this point we can, for example, move this variable inside. Because it's inside, we now need curly braces like this. Okay, so now it's starting to look more and more like a regular method, and because it's a regular method, we actually need to not forget to call it. Interesting. Like this. As a reminder, in Scala, we usually don't work with while loops, and we actually have do while loops, but they're being deprecated because the do keyword is being used for something similar in Scala 3. We also don't have for loops. We have a thing called for comprehensions, and they're way more powerful and a bit more complicated, but we're going to get to them. Let's actually start playing around with something even more interesting, something more fun, and fun stands for functions. Okay, so similar to JavaScript, which these days has arrow functions, in Scala, functions can be passed around. Functions are values, functions are objects. So we can have a function over here, and we need to specify its type. And its type, the syntax for the type is going to be like this. We have the argument list, which is going to be like an int and character and string, right? So this is going to be a function that takes 3 things and produces a string, for example. Okay. Now in this particular case, we're going to need a function that will simply take an integer and produce a string. And because it's only one thing, we actually don't need these params over here. Okay, we're going to use the function over here. We're going to call it over here facc, and because of this we actually need to pass in a function. Okay, so for now we don't know how to use the arrow syntax to declare a function, so we're going to use a method. So we're going to do rendered and int and of a string over here. So we're going to do console.yellow, okay, plus n plus console reset. Okay, and we're simply going to put rendered over here, and as you can see, all of our numbers are now being rendered in yellow. Notice that we're not calling rendered over here, we're not passing in some number, we're passing the actual method. And this is the thing that we had in the beginning. Remember, in the very beginning we had something like def function, and it was defined like this. Okay, and then we did something like print line function, and it was saying that in Scala 3 an unapplied method like this will be ATA expanded into a function. ATA expansion is a simple process of taking a method, or something like a def. As a reminder, the line is blurry in Scala, to take something like a def and convert it into a function, right? Because it needs to be an object at runtime, right? It needs to be something that you can pass around. This is the syntax. Let's actually rename this interesting into a higher order function, because the functions that either take another function as argument or they return other functions from them, they actually they're called higher order functions. They're functions of a higher order. And as a reminder, I always prefer to specify the return type of my methods. Okay, So let's remove these guys like this. Okay. Let me show you a couple of examples of higher order functions. So for example, this is a list of 1, 2, 3, and we can do for each, and we can pass in print line. Okay, again, like print line is a method. It is being converted into a function that takes, in this particular case, a number and does something with it. In this case, does something side effecting. The result of this entire expression is going to be a unit. So if we hover over unit, we're going to see that it's a unit because we called for each. Over here, if you look at for each, this is how it is defined. As you can see, there is a type u that is defined in rectangular brackets. So as a reminder, this is for generic. So we can also manually specify that our print line is going to return a unit. Okay, this is not the unit that is being returned from for each. Okay, so this is this unit. Okay, this unit is this u. Okay. In any case, let me show you a couple of ways how we can also create functions. Okay, so the first one is that when the type is known, okay, then we can just do at the expansion over here. The type was known, and therefore at the expansion worked. If the type is not known, then in Scala 2, so if you do F2 over here, if I remove the type, and then Scala 2 will assume that you just forgot to call this function. Okay, it will just assume that you forgot, and therefore the type over here is going to be a string because this function returns a string. Okay, however, you can also use an underscore, which is specified over here, which is a weird syntax, and in Scala an underscore is usually used in many places across the language, in the places where you don't really need to name a thing, or you're using a thing only once and things like this. We're going to use underscores quite a lot. Okay, I want to demonstrate real quick that you can actually do this in Scala 3 without it. Okay, so if we do like function, okay, and it's like it's an integer and it's like 1337, then if you do like val blah, then you can just do function, and in Scala 3 is not going to actually, what does it do? It's actually interesting. I actually kind of assumed that it would just do this. Okay, now it thinks that it's not a function. Let's actually take do something like what we did over here. So let's actually just do like and toString. Okay, so now it should actually work. Yeah, so now it worked. As you can see, now it did add expansion without you having to specify this underscore. It worked exactly the same way. All right, let me throw this out, but in Scala 2, you still need to specify the underscore. And by the way, even though Scala 3 is going to come out very soon, it's going to take the industry like a year or so to actually move to this version. Okay, now another way to create these functions is by using functional literals, and they are virtually the same as the arrow functions in JavaScript. So for example, you're going to say, okay, some x is going to come in, and we're going to call rendered, and we're going to pass in the x. Okay. So it's going to be exactly the same function. The type is going to be int to string. No need to specify the type. Okay. And another cool thing that JavaScript does not have in Scala, this is very, very specific to Scala, is that in this particular case, we're saying, okay, some argument will come in, and we're going to put it over here. And Scala allows you to have a convenient syntax for this, which basically says, hey, I don't care how we're going to name it. Whatever is going to come in, just put it over here. And again, the underscore is going to be used. And so we don't need to use this x over here because we don't need to name the variable. And we also don't need to use an arrow. And so this thing is actually becoming, you cannot call it an arrow function if it doesn't contain an arrow function. Okay, I'm actually going to save this without formatting. As you can see, this is going to be exactly the same function. So we can go over here, right? And we can do when I bubble lines, VS Code fucks up the formatting here. So higher order function, and we're going to call F1, we're going to call F2, I'm going to call F3, we're going to call F4. They all behave exactly the same. Okay. Now I know that this is a bit weird. Essentially, the rule is very, very simple. In fact, let me actually show this to you. So if we do print out, okay, so we're going to have a list of 6, 2, 5, 9, 8. Okay, so these numbers are not sorted. So we can call a function called sort with, which wants a function which accepts two parameters. Okay, the first parameter we're going to call A, the second parameter we're going to call B. It's an arrow function, so we're going to have an arrow. And we're going to say, okay, so as long as A is smaller or equal than B, then this is how you should sort them. And as you can see, they're sorted according to this function. Okay, and now we can use this fancy syntax. Okay, so we can go over here. We're going to say, okay, so something is going to come in. We're going to use it only once, and we're going to use it in exactly the same order as it is being defined. So A is being defined first, therefore we're going to use it first. Okay, B is defined second, therefore we're going to use it second, and we're going to use them only once. Therefore, we can have an underscore over here, we can have an underscore over here, and we don't need to have this whole thing over here. All right, so I'm going to have it like this so that you can see that it's basically the same thing. Okay, so this is our A and this is our B. I'm going to save this without formatting again so that you can see that it behaves exactly the same. I know that it's, this is one of those things that I said, like Scala syntax can be very, very concise, sometimes too concise. Okay, if you're not familiar with this looks super weird. Let me also show you real quick that this syntax actually does not work with string interpolation. So if we go and do if I call the higher order function, okay, so if I do something like, okay, some x is going to come in, and we're going to do console dot yellow. Actually, let's do something else. Let's do console green plus x plus console reset. Okay, so this is just a regular function. We don't need to put it in we don't need to put it in a val. Let's actually comment this out. Okay, we could use an underscore, right? So we can just remove this and use an underscore over here, like that. Let's actually comment this one out. There we go. Now, if we use string interpolation, let me actually do this and that. Okay, so if we do like as and open the quotes over here, we close them over here, we're using a dot over here, so this is a bigger expression, so we need the curlies. And by the way, notice that if you forget the dollar, then the syntax highlighting is going to be wrong. So this is the sign. If you put a dollar over here, then the syntax is going to be fixed. Same thing over here, like this, and the dollar over here. Okay, dollar. Come on, or the money symbol. We don't need the pluses, we just need the x. Okay, and the x is going to be also dollar. Okay, like this. So as you can see, it behaves exactly the same. However, you cannot use the underscore with the string interpolation. Okay, so if we do this, if you try to do this and do that, you're not going to be able to use the underscore. In general, this is a syntactic sugar, which means that there are many situations where it doesn't work. Now, another thing that you should probably know is that if a function has only one argument, like for example rendered, it has only one argument, or print line, it has only one argument, then you can replace the regular parens with curly braces. Okay, so for example, instead of saying print line hello world, you can actually also do a print line and use the curly braces over here, curly brace over here, curly brace over here. Okay, well, my formatter rewrote them for me, but if I were to do this and that, it would be fine. Okay, so this is exactly the same code. The rule is simple. If there's only one argument, then you can do this. Okay, so for example, we can call the higher order function, and we can specify the arrow function. We call them lambdas, like this: x arrow to the right, and then over here, console dot let's do magenta plus x plus console dot reset. Okay, so in this case, the language is sort of like growing. This sort of looks like a control structure in a language, right? It sort of looks like if x equals 5 or something like this, and then curly braces. Okay, let's remove this. All right, now I introduced this syntax because Scala has a concept of partial functions. Now, whereas a total function like this one, it is defined for all integers. Wherever integer you're going to stick in, it's going to work. Partial functions, they work only on a subset of all the integers in this case. Okay. Now, it is very important that for the partial functions, you always need to use the curly braces. So, for example, over here we're saying this is going to be a higher order function, and the syntax goes like this. So I'm going to press enter over here, and I'm going to join the lines. Okay. So instead of just saying x, we're going to say case x. Okay, so now it's going to pattern match on this pattern. Now this pattern is simply naming a variable, and therefore this pattern will match everything that will come in. However, we could do something like 4, right? So if it matches 4, then it should print out the 4, and let's actually change it to something like sign. Okay, so the first thing that is happening is that we actually need to specify all of the cases, because otherwise it will actually explode at runtime. So we actually need to say, okay, if it's something else, if it's not 4, well, then just return some other string. Remember, like this function, it actually needs to return the string. So one way to think about a partial function is as a function with multiple entry points. Okay, so it's like passing multiple functions, this one and this one. So if it's 4, it's going to be turned into sign and printed out. Otherwise, it's going to be an empty string. Or we can actually name this thing that is otherwise. Otherwise some x is going to come in. And we're going to say, okay, just leave it alone. Okay, well, convert it to string. Because over here we are forced to convert the string. Like as you can see, like the 4 is actually in sign. Let's actually make it green. I believe you guys will be able to see green much better. Now, as a reminder, like this here is a name variable, and therefore if we try to do something like 4, it will simply think that this is a variable. In fact, it will tell you that this line over here is unreachable code because this pattern already matches all of them. By the way, this case thing is sort of like is similar to like switch statements, but you don't need to break them, and it's more functional, more expression oriented. Okay, so if you do just for, it will actually match everything. Okay, now if you have a variable for, then you might be confused, like, why is this not working? There is a hack to work around this by having quotes, or double quotes over here, not double quotes, like back quotes, and we need to not forget to do the underscore and to do like the, basically the other, other dot toString, and therefore it will actually catch the for. And by the way, notice that we did not use any weird name. We can actually use it over here without the quotes. Or if you have constants, and this is why it's a convention to call the constants starting with a large with a capital letter like F over here, then you actually don't need the quotes. You can actually do for, and therefore you can also use for over here, and it will match only the for. You can also have guards. For example, if I remove this, and we could say, let's say that it's going to be some number, but only if its number is divisible by 2. And by the way, notice that we don't need the parens around this if expression, like around the regular if expression, you would need the parens. Around this thing, which is called a guard of a pattern, you actually don't need to do this, okay? So only if it's divisible by 2, only then make it green. Okay, so as you can see, only like the even numbers are painted in green. Okay, now pattern matching and these partial functions, they can be used in more places in the language, not only when you need a function. By the way, like a partial function, it sort of extends a regular total function, and so this guy over here, it says that it wants a total function, but we can actually pass in the partial function, which is not super safe because again, the partial functions, they might fail at runtime because they're simply not defined for every value in the type. So let me actually show you the match statement, which is another place where the pattern matching or partial functions can be used. So as a reminder, everything is an expression, so everything can be stored in some sort of result. Okay, so we can do like list of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And now we're going to do match, which is a keyword. Okay, so sort of like switch, but like switch would usually be like over here in a language like Java or JavaScript or whatever. Match is over here, match is an expression, and then inside of it you're inserting your partial function. Okay, so for example over here I'm going to write a very complicated pattern. I'm going to say, okay, I only want to match if this list contains at least 2 elements. I don't care about the first one, but they need to at least be there. The third one I want to call third. I want to bind it to third. The fourth one I want to bind to fourth. And then maybe there will be some elements. Maybe there won't be any elements. I don't care. Okay. And then I'm also going to hang a guard on this thing. I'm going to say if third equals fourth minus 1. Again, notice that we don't need any parens. Okay. And then in this case, arrow to the right, we're going to return true. Okay, and in any other case, we're going to return false, like this. Okay, so as you can see, the type of result is Boolean because in every branch we're returning a Boolean. By the way, this pattern matching and partial functions, they can be thought of as a really fancy syntactic sugar on top of if expressions. Okay, so let's do the next one. So let's do the next one. For example, let's actually print it out first. Let's print it out. Okay, we're going to see true. Okay, so let's say that we're going to remove all of these guys, right? Now it's going to be false because it doesn't contain the fourth element. Okay, so if we do like the fourth one, then it's still going to match, right? Because like this thing can be 0. As you can see, it says true over here. Let's also do like a 4 over here, right? So now it has 4 elements. Like this one is bound to a 4. This one is also bound to a 4. However, this one didn't match, and therefore we're over here, and therefore we're returning a false. Okay, now yet another place in the language where you can use pattern matching, is in vals. So it turns out that when you use vals, and everything between the val and between the equal sign is actually a pattern match. Okay, so over here. So let me actually comment this out. Okay, so what we can do is I can do this. Okay, so let me go over here. I'm going to do val, and then I'm going to do this pattern. Okay, so I'm just going to copy this entire pattern. Val. Okay, the pattern is going to go over here, and then I'm going to do equals. In fact, let's change this pattern a little bit. Let's not have the if guard. I'm actually not super sure if the if guard can be there. I actually don't think that it can be there. Okay, you cannot use guards over there. Okay, so we're just going to do this, and also I'm going to bind the rest. We're going to use the at symbol to this pattern. Okay, so if there is any rest, it will be bound to this. Okay, so now if we do list 1, 2, 3, 4, 5, 6, 7 over here, we're going to go and we're going to do print line. We have a variable called third, fourth, and the rest. Okay, third, fourth, and this is the rest. Okay, now if we change this a little bit, right? So if we go to like 4, or something like this. It's going to be like this. This is an empty list, okay? And if we remove the for, and this is a dangerous one, right? Because in a partial function or in a regular pattern match, you can specify all the cases, and then you can make sure, even though the compiler does not know that you covered all the cases, in some cases they actually can. I'll show this to you a bit later, but you can be sure that you covered all the cases, okay? But over here, the only thing you can is you can specify only one pattern, right? So you can specify only one of these entry points, and therefore if it doesn't match, it will actually throw an exception. By the way, just for fun, let me also show you, let's comment this out. Let's go and do val 1337 equals 1337. Okay, so this thing works. And by the way, there's something wrong with syntax highlighting. I believe it's too many comments. Let's actually remove all of that stuff. I'm not sure if we're gonna need this. I'm gonna leave these guys in there. It's probably a VS Code thing. Look, I'm gonna close the file. I'm gonna reopen it, and it's gonna mark val as a proper keyword. No, it doesn't do that. I'm not sure. So this is just a limitation of VS Code in this case, because it sees a number over here, right? So if you do like an N, then you would see like proper highlighting. But in fact, like as a reminder, like this can be a pattern, right? In this case, it will only match if it matches this number, right? So if I do 1338, it will actually throw an exception. It's actually kind of fun. I remember this Hopta, this appeared on Reddit at one point. Like, how can you use this, or how can you, how does like this compile? Like, what is this? And also like. And again, I'm just trying to confuse you a little bit. Recently in Scala 2.13, Scala added an ability to create a type on the fly based on a literal. Okay, so we can say that this variable, okay, this x over here, it is going to be of type, not int, but of type 1. Right, which means that if you do like a 2 over here, it's not even going to compile. It's going to say, hey, I'm only going to compile if you're actually going to give me the 1. And so you can write like stupidly funny code like this, while 111, and everything compiles and sort of runs. And you can, you cannot print it out because you did not assign any names to it. Okay. In any case, I just wanted to confuse you a little bit. All right. Let's actually talk about exceptions. Let's actually remove everything over here, and let me actually print line 1 divided by 0, and it's going to throw an exception. It's going to throw a Java lang arithmetic exception with a division by 0. Now there is a way to catch them. And the way you do this, and again, the same rules, if you have only one expression, then you don't need curly braces, you do try, you have a catch. Over here, you have a pattern match. What a surprise. If it's an arithmetic exception, right? So this is a pattern match that we're seeing. This is a pattern that we're seeing for the first time over here. We're pattern matching on the type, and if it matches the type, we're going to assign it to this variable. In this case, we're going to do print line console.read plus e plus console reset, like this. Okay, and as you can see, it's over there. We can also do dot get message, like this. Okay, and we can also just there's a method on the exceptions called print stack trace, like this. You can also make it read by using print, not print line, console.read, and over here, console.reset. Okay, and the whole thing is going to be read now. As a reminder, again, Scala is a very, very regular language, so the try catch is also an expression, so you can assign it some result. So for example, let's say that we would actually handle the exception properly, right? So we'd say, okay, if there is an arithmetic exception, then we're actually going to return a 0, right? Then the result type is going to be, in this case, it's any val because I forgot to remove the print line, right? So it's going to be like this. So in this case, it's actually an integer. Okay, so we can also have a finally print line. Same deal. If it's one expression, you don't need curly braces. No worries. It's all good like this. Okay, and now we can print out the result. Okay, the exception was thrown, it was caught, therefore this 0 was assigned to this result, and therefore the type of this whole thing is actually int, like this. Okay, now I have entire videos dedicated to pattern matching because I didn't show you exactly the syntax like for how patterns are being created, how you can write your own patterns, what is a pattern, what is not a pattern. So I have like full-blown videos dedicated to pattern matching and partial functions alone, so check them out if you like. Now let's finally talk about collections, and the first thing that you need to know about them is that we have like two kinds of them: the mutable ones, meaning that you can change them in place, and the immutable ones, meaning that the only way to change them is actually by creating new ones. We're being encouraged to use the immutable collections, big surprise. And we're being encouraged by the fact that we don't need to use their fully qualified names, or we don't need to use any imports, right? So we can just go and we can say, list 1, 2, 3. Okay. So with the exception of arrays, all the mutable exceptions, all the mutable collections actually need to be imported into scope. And by the way, in Scala, the imports, they can live anywhere. They don't need to be only at the top over here. In fact, let me show you the imports in just a couple of seconds. Let's start slow and talk about arrays, okay? So we already have an array over here, but let's create our own, okay? And this is one of the places in Scala where type inference helps a lot, okay? So we don't need to specify the type of the array. It will see, oh, there are strings in there, therefore it's an array of strings. Okay, so I'm going to call this one apple, this one is going to be orange, and this one is going to be a banana over here. By the way this thing works is that there is an object called array, and inside of it there is a method called apply. And in Scala, in the compiler, there is this there is a syntactic rule that if something is called apply, then you don't need to call it. Okay, there are a lot of important places in the language where this is necessary. In fact, I'm actually going to show you one of them now. So we're going to do this const2, and as you can see, there's zero base, so this is the zero, this is the index 0, this is the index 1, this is the index 2, and so at the position 2, the third element is banana. And as you can see, like in most languages, you would use like rectangular brackets over here, but we can actually not use them because we're using the rectangular brackets for generics. Okay, so in this particular case, we actually need to use this. And if you look at this, how does this actually work? Like this is a val. We can only call methods on it, right? So and it works exactly the same way. This method happens to be called apply. This is exactly how it works. Okay, so this is another use case for apply. Okay. Now we're going to see that even though we're using a val, because the collection is mutable, this is actually not a constant. Okay, I mean, sure, we cannot reference any other object, but we can mutate the object, and therefore it's not a constant. Okay, so we can do constant2 equals melon. Okay, and now we can print it out, and we can see that that's at the same position. It's not a banana anymore. It's a melon now. Okay, therefore this cannot be a constant. Therefore let's actually call it fruits. Now on the collections you have you know, the typical you know, we have like a lot of useful functions. So you know, you can just go over here. You know, there's collect and collect first, compose, concat, contains, like all of the others. But for now we're simply going to use for each print line, and as you can see, these are all our fruits. Okay, now because this is a mutable collection, we actually have methods to mutate it in place. So we can do map in place, and we're going to take every element and we're going to do reverse again. Like this is just a better syntax for, you know, some fruit comes in and, you know, fruit dot reverse. Okay, we're just going to go and use an underscore over here. We're going to map it in place, and then we're going to do for each print line, and we're also going to do fruits for each print line, right? So I'm just going to bring this one down. Okay, so both of them were reversed, right? Let's actually do this. Let's actually do that. Let's actually do that. Okay, so this is how it was in the beginning. Then we reversed it, but it was reversed in place. And so when we're doing fruits for each print line again, then we actually have this. We also have like the functions that are usually used on immutable collections, right? So we can also do map, and then we're going to see that the original one was actually not reversed. Okay, but it's super weird to use like these immutable functions on actually mutable collections. Okay, now this is enough about the arrays. Let me actually show you where the mutable collections are. So you can do like scala.collection.mutable. And as you can see, there is a abstract buffer, array buffer, builders, you know, there's a bunch of them. We have like hundreds of them. Okay, so you can also import everything. I highly recommend you to never ever import it like this. Okay, because now you're shadowing the immutable collections. Okay, if you want to deal with mutable collections, simply import this, import mutable. Okay, so now you can do val blah equals mutable dot, I don't know, array seek or something. I actually have no idea how to create. Oh yeah, that's how you do it. Array seek, you know, 1 2 3, you know, print line, blah, and there you go. Okay, so this way you see it right away that you're actually dealing with a mutable collection. By the way, another thing about imports is that imports can actually work for anything, not just for packages like they do in Java. For example, let's say that we have an object my stuff. Okay, and inside of it we have a val called inside 1337. Okay, now over here if we try to print line inside, it is actually not going to work. However, we can import my stuff, and we can either import everything inside, or, you know, just this one variable. It's super cool. As already mentioned, like Scala is a very irregular language. There is no need for imports to work only for packages. All right, let's finally talk about the immutable collections. Okay. At the very top of the collections hierarchy, which is very, very large, there is a collection called iterables. So you can do something like print line iterable of 1 to 3. Okay, it's just an iterable, and as you can see, the default iterable is list. Now, what you need to know about the collections is that all of them are homogeneous, meaning all of them need to have exactly the same type, right? And if you ruin something like, if you do something like this, it's not a string, then the type is going to be iterable if any, right? Before the inference was saying, that it was int, iterable of int, then it, you ruined it and you turned it into any. Another thing that you need to know about them is that their size is dynamic, right? So you can add elements or remove elements, right? So it pretty much works for all of the collections with the exception of the arrays, which are mutable anyway. Okay, now in Scala there are basically 3 major branches in this collections hierarchy. One of them is sequences, the other one is sets, and the third one is maps. Okay, sequences are basically ordered collections, similar to arrays, but they're immutable. Okay, sets are unordered, and the sets cannot contain any duplicates, and maps are simply sets of keys and associated values to them. As you can think about it as associative arrays. You'll always associate some key with some value, and because the keys is a set, you cannot have duplicate keys in there. Okay, so like the next time you're gonna insert the same key, you're basically just gonna change the value of of the corresponding value. But again, we have mutable maps and we have immutable maps. So what I just said, changing the value will construct an entirely new map where in the position of this key is going to be a new value. Okay, let's have a couple of examples. So this is going to be a sequence. Right, as you can see, the default sequence is actually a list, which is like this. So you can go specifically create a list. Also, the sequence branch of the collections tree is actually divided into 2. One of them is like the any sequence, and the other one is the index sequences. And the index sequences is the one that guarantee constant time of the index access. Right. So, for example, we have a list 1 to 3. We can actually access the element at the second position over here, right? Which is going to be, the 3. However, it's not going to be efficient. It's going to need to traverse the list to actually find this element. However, if this was an indexed sequence, like over here, right, the API is the same, but the performance, the algorithmic complexity behind the scenes is better. Okay, so the default indexed sequence is actually a vector. Let me actually show this to you. It's vector. So as you can see in both cases, you see the vector. Okay, so now let's have a set, and sets cannot have order or duplicates. So if we do like 3, 2, 1, whatever, like all the duplicates are gone. Okay, and we can also do some specific ones. So for example, we can do Scaladoc collection immutable.hash set. I wanted to show you that the default set is the set that bases its duplication on the hash function. However, there's an optimization in Scala that the sets until 5 elements, they're actually they have like specialized implementations. Okay, so if we do 4 over here, it's still gonna say set. If we do 5, it's gonna say hash set. Okay, so the default one is hash set. As you can see, there is no order and there are no duplicates. Now we're gonna see maps in a bit. Let's actually start playing around with these guys. So same as with arrays, we can do list 1 to 3 for each print line, for example. Okay, let's duplicate this line. Let's also do list 1, 2, 3. Let's do a map, right? +1. And as a reminder, we're not mutating this collection in place, right? So it creates another collection, and therefore we can continue our chain of function calls, right? So we can do for each print line. Okay, so now every element was having a +1. As a reminder, this is just something comes in and then being done x +1. It's exactly the same thing. Okay, but I'm gonna do just this. Okay, another one that we're gonna do is, let me actually duplicate this line, bring it over here. So we're gonna go and we're gonna use filter, and we're gonna say, please give me only the odd ones, right? So only the ones that are not equal to 0, right? So as you can see, like this syntax is very convenient even to read once you get used to it, right? You just say, okay, I have a list, filter the ones that modulo 2 are not equal to 0, and then print them all out. And as you can see, the 2 is not being printed out. Okay, it is also very convenient to press enter over here, and then a Scala FMT will format it in such a, I believe it's called method chain notation. Okay. Also notice that we can also map afterwards, right? So we can do like +1 over here, right? So we got the odd ones, and then we did +1 on 1 and 3. Also, if you switch them, the behavior is going to be different. Okay, so now we did +1 first, right? So we had like 2, 3, 4, and then we figured out the odd ones was only the 3. Okay. Now the next one is going to be a little bit more complicated. So what we're going to do is we're going to do list 1, 2, 3, and we're going to call, instead of map, we're going to call flat map. Okay, now everything is typed in Scala, and so the difference between map and flat map is that the function that the flat map wants, it actually needs you to produce anything you want, but it needs to be wrapped in another iterable, right? In this particular case, it's iterable ones, but for the most part, like think like if you're doing it on a list and it wants a list. Okay, so over here we had a function that was going from integers to integers. Over here we need a function that goes from integers to some list. In our case, it's still going to be a list of integers, but still it needs to be a list. And therefore you can actually use it to implement filter, right? So I'm actually going to remove this map, and I'm going to go over here and I'm going to say flat map. Okay, and I'm going to say, okay, so there's going to be some number. Okay, and if this number is odd, I'm sorry, if it's even, then I'm going to produce an empty list. Okay, this is one of the ways to create an empty list. And otherwise, I'm going to create a list with only this one element. And in effect, this actually created exactly the same filter. So if I go and do for each print line over here, Scala FMT will change the indentation for me. But as you can see, we implemented in effect exactly the same filter. This is also another way to create an empty list, just like this. All right, but I prefer to do list.empty. Now, map and flat map, they're actually oddly familiar with the function called and then on promises in JavaScript. And in fact, we also have some like promises. We actually call them futures, and we can use map and flat map on them the same way you would use and then on them. But we're actually not going to play with futures today because this crash course is going to get way too long anyway. All right. Now, usually you use flat maps when you're dealing with nested collections. Okay. So let's say that we had some sort of a matrix. Okay, we're going to have matrix. It's going to be a list of lists. List of lists. Okay, so the first one is going to be list of 1, 2, 3. Then we're going to have a comma, duplicate the line a couple of times. Let me actually scroll down. This is going to be 1, 2, 3. This is going to be 4, 5, and 6. And this one is going to be 7, 8. Oops, what happened? 7, 8, 9. Like this. Okay. By the way, notice that Scala FMT actually removed the last comma. There's actually a rule in Scala and Scala 2.12 that you can actually leave the comma in there if you're calling the function. By the way, this is just a function call of list apply. Okay. If you're calling the function, if you specify the arguments on each individual line, you can actually leave the last column. Okay. So if I save without formatting, as you can see, the comma is still there and the code works just fine. All right, let me actually remove this. Let me actually do matrix for each print line. And by the way, remember this again, like this is a method, right? But you can use the infix notation, matrix for each print line, same way, right? All right. So we're printing out every element of the list. However, every element happens to be a list on its own. So this is how it looks like. Okay. Now, what we can also do is we can go and we can say matrix.flatten for each print line. And what it will do, it will just press all of these lists together and create only, create one list. Okay. As a reminder, like everything is an expression. So if we go and if we just print out the matrix.flatten, you're going to see that it's just a list with all these elements, right? So all of them were just squeezed together into one and added together. Okay. Now the combination of flat map and flatten is, the combination of map and then flatten is actually exactly what flat map is. All right, so what you can do over here is, let me do this, let me do that, okay? So for example, let's say we take the metrics and we map every list inside of them, right, to the reversed version. And then we're going to flatten it, and then we're going to print out all of these lists. Then you will see that, the first list, 1, 2, 3, was reversed. The second list, 4, 5, 6, was reversed. The third one, 7, 8, 9, was reversed. Then they were flattened into one big list, and we just printed out each individual element. Okay, now it turns out that you can do exactly the same thing by simply saying flat map over here and removing the flatten. Okay, this happens because we already had a nested collection, and therefore we call the reverse on the list. Therefore, like, remember, the function that is passed to flat map, it actually needs to produce another list. Well, reverse on the list, it actually produces a list. Okay, so as you can see, it behaves exactly the same, produces exactly the same thing over there. Okay, now let's talk about maps. In fact, maybe we should create more space because we did so much. Okay, so we're going to do print line map. And what is inside of the map are tuples, and tuples are heterogeneous collections, right? So they can contain elements of different types. However, their size is static, right? So you have a tuple 2, it can only have 2 elements, right? The types can change. They're immutable, okay? You can only create new ones and you can change the types, but their size cannot change. Okay, so this is the syntax to create them. You just say 1 and 1, for example, right? So this is going to be a map, and as you can see, it's drawn like this. It's like an associative array. So the key of 1 will have the value 1. Okay, so we have this one, and I'm going to copy it. I'm going to do comma space paste, comma space paste. Okay, so this is going to be the 2. This is going to be the 3. This is how it looks like, and it turns out that in Scala you can actually use exactly the same syntax to actually create them. Okay, so I'm actually gonna copy this, and I'm going to do print line, gonna put it in here, but these guys are strings, so I need to surround them with quotes like this, and like that. Okay, so as you can see, this is exactly the same map. So right, you can sort of see like a key value, right? A bunch of key value pairs. Now I'm presenting maps to you too, so that you can learn about tuples and how to work with them a little bit, because we're going to need them. So if we have a map and we call the function map on it, right? So what's inside of it? Well, inside of it is the tuple 2. Okay, so basically this means that there's a key in the first one, and it just has the field members that are just called with _1, 2, 3, and so on, right? So it just called 1, and the value is in the second one, right? So it's a tuple 2, it has 2 things, okay? And now we can create another tuple, right? Like the similar as we did over here. We're going to create key value to lowercase, okay? So we're essentially mapping every key value pair inside into this, okay? Basically also what's happening, not tupled. Okay, also be very careful. I call it tuple 2 like this. What is happening to lowercase? I'm getting tired because this crash course is getting way too long. Okay, let's not forget to actually print it out. Let's print out every element. Let's do for each print line. Okay, be very careful because the maps cannot contain duplicates. So if you ruin the key by using, I don't know, 1 over here, right, then all the duplicates will be thrown out. Okay, so it will just take like the last one and will replace these ones. Okay, now I'm doing this to show you that again, like map wants a function, but you can also pass it a partial function. Remember, partial functions can always be used at the place where a regular function is used. So it turns out that we can actually take this code over here and do this, maybe actually duplicate this print line, put it like somewhere in the middle. Okay, so we're doing the same thing twice. So now over here, instead of doing like this guy, we can actually do like a partial function. We can just simply say case, and we can deconstruct. It's similar to, I believe they're called destruction in JavaScript. We can just like take the tuple apart. We can just say key value equals, and it's going to be not equals, like the arrow function, right? And it's going to be like this, right? So this is exactly the same code as above, but much shorter. Okay, also you can sometimes do this, but I personally don't like this. I prefer like the case to be on its individual line. Okay, so a tuple comes in, we're taking it apart right away. We don't need any other cases because this case will always match. The first element will be assigned to the key, the second one will be assigned to the value, and then we're doing exactly the same thing. Now that we know about tuples and about how to destructure tuples, remember the patterns can be used between the val and the equal sign. So what we can do is I can show you the function called partition on lists. So if we're going to have a list 1, 2, 3, 4, 5, 6, just 6, okay, and I'm going to call partition, which is similar to a filter. It won't say predicate, so we're going to say partition like a list. Then what it will do, it will return you a tuple 2. Okay, so as you can see, like the tuple of this, the type of this is a tuple 2. Okay, and so we can deconstruct it again, right? We can say, okay, like, so in this particular case, this is a tuple 2 of 2 lists, right? The first list is going to contain the even ones, the ones for which this expression was true, and the other one is going to contain the odd ones. So we're going to have even, and we're going to have odd. We can print line even, we can print line odd, like this. Okay, we have these 2 lists with even and with odd. Now we're getting, now things are starting to get more fun because now we understand tuples and we can talk about ranges. Okay. A range is a collection of numbers which are like always incrementing or decrementing, but they're implemented in a very, very efficient way. Okay, so you can create a range by doing something like please start at 0 but end at 10, and at 10 let's do a for each print line. Okay, so so you go from 0 to 9. We can also just simply print it out, so that you can see that this is just a range, print line range. So it looks like a range from 0 until 10. Okay, now you can also specify a step. Okay, so you can go over here and you can say step is going to be 2. Let's have this in there. Let's actually do it like this. Okay, so now you see only like 0, 2, 4, 6, and 8. Okay, now when we printed it out before, so print line, and we had this range in there like this. As you can see, it says this is a range from 0 until 10. You can also have an inclusive range, okay, that includes the 10. In fact, I'm going to let it go to 9. So everywhere where I say 10, I'm going to say 9. And over here, everywhere I say range, I'm going to say range dot inclusive, right? So range is just an object. Inclusive is just a function defined on it. We're just calling it with the same parameters, except for, we're going until 9. So as you can see, it's exactly the same range. It's printing out the same way, 0 until 9. We actually need one more of these guys. Okay, so except for the ones with the steps, right? All of the print lines, they look exactly the same, right? So this is the last one, 0 to 9, 0 to 9, 0 to 9. I don't know where the 0 comes from. All right, now it turns out, like, because Scala is such a fancy language, it actually allows you to create both inclusive and exclusive ranges, which was a much more convenient syntax with this one. So you can just print out 0 to 9. So this is the exclusive one, and until 1 is the I'm sorry, like this is the exclusive one, and this is the inclusive one, right? So this is the until, this is the to. Okay, which means that if we do for each print line, let's actually do a 10 over here until 10. So 10 will be excluded, right? And over here, the same thing, 0 to 9 for each print line. Okay, and you can also do by. Okay, so you can do 0 until 10 by 2. Okay, and over here, 0 to 9 by 2 for each print line. All right. Great. And again, like this is just a syntax. Okay, so until is just a function defined on integers. 10 is just an argument. Then it returns you something that has a method called by. 2 is just an argument. It returns you something that has a method called for each, and print line is just an argument. Okay, so all of this, you can write it like this if it's more convenient to you, right? But it's just basically a bunch of function calls. It's just a more convenient syntax. Okay, and because the syntax is so convenient, our 4 comprehensions, they can look like 4 loops, and we're going to start talking about them. So what we can do is we can write 4, which looks sort of similar like in any other language, and we can say, okay, whatever comes out of this range, 0 to 9, right, 0 to 9, then just take it out and assign it to the variable, and I'm going to call it I, right? So we're going to have this arrow, assign it to I. As always, if we're doing only one thing, then we can just, we don't need any curly braces. So as you can see, this looks like a regular for loop, but it's actually a for comprehension. You can stick any collection in here. It will just go through it, and you can stick in any other thing that has very specific methods on them, and we're going to see actually why. As always, everything is an expression, right? So we can do interesting over here. The type of it is going to be unit. However, if we actually put a yield over here, yield, right, then the type is going to be now index sequence of unit, right? So basically it had a range of numbers. It converted every number to a unit. So if you don't convert every number to unit, but if you convert every number to, I don't know, i+1, for example, then this will become an index sequence of integers. Okay, and so now we can do interesting for each print line. Okay, like this. Okay, what is even even more interesting is that let's call it even more interesting is something like this. I didn't show you, but you can actually create ranges out of characters. So let's say that we wanted to create a chessboard. So we're going to say that this is going to be the character, the chessboard goes like, A1, A2, A3, right? So we're going to go from the character A to the character H. Okay, we're going to yield, and inside of the yield, we're going to yield another 4. So we're going to do 4. Okay, over here, we're going to have the numbers. Over here, we're going to have the numbers from 0 to 8. And then we're going to yield the character and arrow to the right and I spelled it wrong, yield. Okay, character to the end over here. Okay, let's actually see what is happening over here. Okay, we're going to see an index sequence of an index sequence, and we already know that we can flatten things like this. I'm going to have parentheses around this so that I can call flatten on it. Okay, and now if I do even more interesting, I go over here, I do for each print line. By the way, we created a tuple over here. I sort of like did it like way too fast. Okay, then we created a bunch of tuples. It was the entire chessboard. You know, it started with A0, A1, and ended with H0. You know, like until 8. Okay. Now it turns out that like this fourth thing, it can actually, you know, like we already worked with like these flattening things. So it turns out that what we can do is we can go and do like even more interesting, and we're going to call it 2. And what we can do is we can take this range, right? This A to H. Okay, we can map, right? We can take every character. Okay, we're going to have another range. We have to 0 to 8. Okay, and then we can map, and we're going to have the n. Okay, and we're going to create exactly the same tuple over here. And look at the return type. It's exactly the same as before, index sequence of index sequence. Oh, well, okay. So we know that we can actually flatten it. You know, maybe we actually also let's have parentheses over here, right? The parentheses were removed for us, but now we actually flatten this thing. So now it's index sequence of character and integers. Okay, so now let's actually go and do for each print line. Oh, well, actually we have the second val. So let's go and do this for each print line. Okay, so as you can see, it's being printed out exactly the same thing. So there's some relation between these 4 comprehensions and maps, and we already know that, you know, map and then flatten, right? So this big map, something inside, and then flatten is the same as flat map. Check this out. If I put a flat map over here, then we actually don't need to do flatten. Okay, it's going to produce exactly the same chessboard. And it turns out that 4 comprehensions, they're just a bunch of flat maps, and the last one is a map. So it turns out that there is a better way to create this chessboard. Okay, so first of all, let's actually start calling it chessboard like this. Okay, so what you can do is, instead of having nested 4 comprehensions like this, well, what you can do is you can do 4. Okay, and now you're going to do like this is going to be the first one, right? So this is going to be A to H. By the way, this thing is called a generator. Then you can have a semicolon. Okay, and then you're just going to have the next one, which is going to be N, which goes from 0 to 8. Okay, and now it's being closed. Now we're going to yield. We're going to do C and N. Okay, so now we're going to take this chessboard and we're going to do for each print line. Okay, so I'm going to call this chessboard 1, chessboard 1. This one is going to be chessboard 2, chessboard 2, like this. Okay, now I'm going to save without formatting. Okay, and it's going to produce exactly the same thing. I mean, we're seeing actually only this one, so let's actually see the first one. See, this is the first one, and it does exactly the same thing. Now I accidentally saved with formatting, and the formatter rewrote it to this. Okay, so I'm actually going to press Ctrl Z. So this syntax, you know, we don't like semicolons. If you use curly braces instead of these, then you can actually run them like on every line. Okay, so as you can see, like this syntax is a bit more pleasant than this, but again, this is not just a for loop, this is a for comprehension. Essentially, anytime you have flat map, flat map, flat map, flat map, and then in the end you're going to have a map, you can always rewrite them to this. Now, flat map is actually a bit complicated, and if this is the first time that you're encountering it, trust me, even 10 years from now, you're still going to learn, learn something about it. So don't worry about it if it was a bit too fast for you. For comprehensions also have the ability to filter stuff. So let's actually not print this one, let's actually print this one. Okay, so if you put over here before the map, if we actually do a filter and let's say just take like only the even ones, then we're going to see that we're producing like sort of like a half of the chessboard. Okay, and you can do the same thing by just having an if over here. If, no need for the parents, exactly the same thing, and it should be I'm sorry, this is the n. Okay, this is the n. Okay, so it should print out exactly the same thing. Let's comment this one out. Let's print out this one, and it's being printed out exactly the same thing. You can also have it on its own branch, on its own line. You can also filter out this one, right? So you can do a character like this. Well, actually, for characters, this doesn't actually make sense. Let's do the characters smaller or equal to b, right? So where we're generating like a small portion of a chessboard. All right, before we take a look at how we can manipulate collections, how we can actually change them, let's actually have a slightly more, well, it's still simple, but let's have another example of a tail recursive function. So we're going to have a Fibonacci. Okay, typical example. So it takes an int, produces an int. Okay, then in Scala it looks very, very tiny, right? So if it's a number that is smaller or equal to 1, then we're just going to do 1. Otherwise, we're going to do Fibonacci of n minus 1, and we're going to do it times n. Okay, like this. So this is Fibonacci, and now that we know about ranges, I can simply do 1 to 9 Fibonacci. 1 to 9. I'm sorry, 1 to let's do 1 to 9 map Fibonacci for each print line. Okay, now I can do everything much faster. Now obviously this is not a tail recursive function, so if we do at Scala dot annotation tail rec, we're going to see that it's not optimized. Now the way you do this is basically by carrying what is being returned with you on every call. Okay, so this is a pattern, which is why I wanted to show it to you. So we're going to call it Fibonacci tail. Okay, now this function is actually not going to contain any recursion at all, but it will have a function inside of it, and this function is going to be tail recursive. Scala annotation dot tail rec. Okay, so and in the end, once we finish writing this function, we're simply going to call it. Okay, now the function is going to accept an x, which is an integer, and it is going to be accepting the result that we have accumulated so far. Since it's going to be a recursive function, we're forced to return we're forced to encode the return type. We're forced to specify the return type. Okay, so when we're going to call it, the x is going to be n, right? So this is the n that was initially passed in, and the accumulation is going to be 1. Okay, and therefore we're going to do basically the same. It's the same algorithm, right? So now we're going to say if x smaller equals than 1, then in this case we're just going to return whatever was accumulated, and in the beginning it's just 1, and otherwise we're simply going to loop again, and our x is going to become x minus 1, which comes from here, and our result, we're going to remember, it's memoization, that we're going to remember that this is our result, right? So this is times x. This is like this part. Okay, so now that we're always going forward, and every time we're calculating something, we're memorizing it, we're carrying it with us, we actually never need to go back. So if I duplicate this line, bring it down like this, and I copy this, paste it over here, we're going to see that we have exactly the same code over there, exactly the same exactly the same result. All right, cool. So now let's finally talk about, I just wanted to show you the ranges. Okay, I didn't want to do this before I had the ranges. All right, now let's talk about how we can actually manipulate, how we can actually change the collections. And again, changing means creating new ones. Okay, so we're going to do a val list equals list of 1, 2, 3, and we're going to print it out like this. So now we're going to print out a 0 prepended to list. And the way this works is that, like, usually when you see this, then this is an infix notation for something like this, right? But Scala has a syntactic rule that if a method or a function, if it ends with a colon, then it becomes right-associative, which means that this is actually a method that is being called on the right thing, not on the left thing. Okay, so instead of this, it's actually list dot colon, and the 0 is being passed in. Okay, and this is done in such a way so that you can write it like this. So this is the 0 is being actually prepended. Okay, I'm gonna write here right-associative. Now this is a very specific one only for lists. If you're dealing with any other collection, any other ordered collection, then you will actually use a plus over here. But again, it ends with a colon, so it's gonna have exactly the same result. Okay, so it's exactly the same as 0. So the next thing that we're going to do is I'm going to show you that you cannot mix the associativity, right? So you cannot do this and not and do like +4 over here, right? So this one would actually add an element to the list, and in this case it actually worked. I'm actually kind of surprised that it worked. Maybe it's not going to work like this. That's interesting. I thought actually that it would actually not work, but it actually does work. Interesting. All right. Now, as you can see, you already see how to append an element, right? So let's actually have it over here, right? So it's going to be this. And as a reminder, lists are singly linked lists. So appending an element to the list, it will have to recreate an entirely new list, whereas prepending is a constant operation. These data structures are sometimes also called persistent data structures because, every time you're creating a new one, it doesn't mean that you're copying the old one. So if you do it properly, it's actually efficient enough in most cases. Okay. Now, this is how you can concatenate lists. So for example, list 4, 5, 6. So we're going to see 1, 2, 3, 4, 5, 6. Okay, and again, this is just for lists. If you're dealing with other collections, then you would do ++. And remember, like, again, all of these, they're simply methods. This is simply an argument like this. All right, great, like this. All right, so I'm going to also show you this colon syntax, why it was created like this. It was created so that you can create lists like this. 3, and there is an object called nil, which represents an empty list, right? So you can also do list.empty like this. It would work exactly the same thing as you can see over here. It just does, list 1, 2, 3. We also can use nil, and you can also use this in pattern matching, but we're not going to do this. Okay, in fact, I'm actually going to remove this one. All right. Now let's go and do the same thing with a vector. It's going to be very, very similar. Let's actually do this. Let's actually do this. Okay. So we're going to do a vector. It's going to be a vector of 1, 2, 3, and we're going to do print line vector, and we're going to do print line, 0, prepend it to the vector, and we're going to have a vector, and we're going to append a 4 over here with a okay, so this is a column plus, this is a plus, whoa, this is a plus column like this, vector plus 4, and because vector is an index collection, behind it is actually a tree of arrays. It actually has an amortized constant time of appending as well. Okay, so if you need to constantly prepend and append, and you need fast indexed access, then use vectors, which is why they're the default index collection. Let's add two of them together, vector plus a vector of 4, 5, and 6. The next one is going to be sets. In fact, let's actually do this. Let's go and say set over here, set over here. Let's call these guys set. Like this. As you can see, sets, they don't have an order, so there's no way to prepend something and to append something. You can only add stuff, okay, and therefore you can only do set plus 0, for example, okay, like this. And over here we do 4, 5, 6, and also let's do let's do the same sets to remind you that there are actually no duplicates, there is no order. The next one that we're going to do is going to be maps. Okay, so we're going to have map is going to be the same map as before. In fact, I'm going to copy paste it from my script not to waste your time. Okay, so whoops, over here, so this is going to be a map. We're going to print it out. Okay, so we're going to print out map, add the same element. Remember, like, no order means there is no way to prepend or append. Plus, and we're gonna have parens, and we're gonna have another tuple over here. We're gonna do 4 like this. Okay, if we do this over here, right, we're gonna do 3, and we're gonna say this one used to be 3. Okay, remember the same key means that whatever the value was before, it will be overwritten. And another reminder is that we're simply recreating the map, right? So the original map, it remained unchanged, right? The original map still has this. Now let's also do map map of 3, which all right, so this is a map with only one element, used to be 3, and then we're also going to do 4 is going to be 4. Okay, so this is a map with 2 elements, 4, and we're also going to do map, and it's going to merge them all together, and the last one is going to win. Okay, so the 3 is going to be 3, the 4 is going to be 4, because at the end we prepended, we added the original map. Okay, there we go. Great. Now, the way you convert between collections is by calling a method called to. So let's say if we have a list of 1, 2, 3, and then we're going to do 2. Now, some of them are already built in, like to list, to array, to buffer, but you can always just call 2 and pass in as the argument the object that is associated with this collection. So for example, we can do just vector like this, and now it's going to become a vector if I spell it correctly. Okay, so if I print it out like this, then we're going to see that this list became a vector. And there's also a way to convert between Java collections and Scala collections. So for example, I'm going to create a hash set. Scala collections, Java collections are mutable, so it's a bit weird to create them. So I'm going to do a new Java util hash set for ints, and we're going to do result add 1, and we're going to do 2, 3, 4, maybe actually do 3, 2, 1, right? Because it's a hash set, and now we're it's a hash set. So now we're going to return it over here. We're going to go and print it out. Print line hash set. Okay, this is the Java hash set. However, if we go and have one tiny import Scala JDK collection converters dot underscore, then we create a Scala set based on the Java hash set. We can just simply call as Scala, and then we can print out Scala set like this, and we can also go back to the Java set by taking the Scala set and doing as Java, print line Java set. Okay, now as you can see, we can actually work with Java collections. However, the Scala collections is simply better, and therefore it's typical to simply convert them. At this point, I want to show you how these methods are being created, because remember, this is always like list.apply, and the way this works is that you simply have an object somewhere. Okay, let's actually go over here. You simply have an object there. Let's call it my collection. Okay, and inside of it there is a function called apply, and it has a variable args parameter list. Okay, so you have a type over here, and then you just have a star. Okay, now if you just return ints, right, we're going to see that after it's like inside of, as soon as it's inside of the body, it will actually be converted into a sequence. Okay, like this. Let's actually do that. Okay, so now if we go over here and we do C1 equals my collection again, dot apply, we can just do this like with an empty one, or we can skip the apply, and if we print it out, okay, we're gonna see that this is like an empty list, right? The default sequence is actually a list. And if we go and do C2, my collection, and we're gonna do 1, 2, 3, 4, okay, and we're gonna do print line C2, then it's being converted to a sequence. In this particular case, it's actually an array sequence, and you can work with it. Like in this particular case, we didn't do anything with it, we just returned it, but you can actually work with it. Okay, there is also a way to enforce that parameters are passed, and you just simply use a trick. You say that the first one is going to be integer and the rest is also going to be integers. Okay, and then over here you simply take the first and you just prepend it to the rest. Okay, like this, and now it's not going to allow you to create an empty one. Now you're forced to actually do something like this. All right, so we're moving very close to object orientation, and before that we're going to talk about function curring. So let's actually remove all of that like this. Okay, function curring can be a complicated concept, but it's actually very simple. Let's say that we have a simple function called plus, takes an integer a int and b int, and it produces an integer, and it just does a plus b. Okay, then we can calculate the result by doing plus, a equals 1, b equals 2, and we can print out the result. No magic there so far. Now there is also another sort of like obscure way to define this function. Okay, so instead of doing this, we could define it in such a way that it's a function that takes only the a. Okay, but instead of taking the b and then producing an integer, it will simply return a function that will want the b, right? And then it will use both a and b. Okay, so it will return a function that will take an integer and return another integer, which makes it a higher order function. Remember, higher order function is not higher order only when it accepts functions as parameters, it's also higher order when it returns functions. Okay, right, so over here we need to return a function. Okay, we need to return a function that will take an integer, and guess what we're going to call it? We're going to call it b, and now it will return the same sum, right? It has access to the a, it has access to the b, so it's just going to do a plus b. Okay, the way you use it is going to be very similar. Okay, but let's do it step by step. Let's extract this function first. Okay, so we're going to do, this is going to be the second function. Okay, by calling plus, we're going to specify that a equals 1. We're sort of like freezing the a. Okay, now we can access the result by doing like second function where b equals 2. However, because this is now like a lambda, this is an anonymous function, it actually doesn't have, you cannot use named parameters, so you can just do this. And now we finally arrived at our result. Okay, now a peculiar thing that is happening over here is that if we don't go step by step, if we don't create this value, if I just copy this, pay attention, I'm copying this, I'm marking this, and I'm pasting, right? So I'm basically substituting. Okay, now I don't need this. The effect in the end is exactly the same, but now it sort of looks like plus is a function which has multiple parameter lists. And in fact, Scala actually has a syntax to declare functions with multiple parameter lists, but behind the scenes exactly the same thing will happen. So if I do this, right, comment this out, and I simply go over here and I do b colon int, right, it's very similar to this, but it's instead of a comma, instead of having one parameter list, we're going to have two parameter lists. Okay, and then it's going to go back to simply returning an integer, so it doesn't need to return a function. Right? So it's going to behave exactly the same. This is just syntactic sugar for curried functions. Functions with multiple parameter lists are called curried functions, or this concept is called function curring. Let me actually demonstrate another example of a curried function in the standard library. And you actually know a curried function from JavaScript. It's called reduce. So if you have a list, or which similar to array, we can call fold left, which is similar to a reduce, and it has two parameter lists. The first parameter list wants the C, like what to do if the list is empty. Okay, it's going to be 0, and another one is going to be a function. It's going to be a function that will, I'm actually going to write it like this, right? It's a parameter list, it's a second parameter list. It wants only one thing, therefore we can replace the parentheses with the curly braces, okay? So it's going to be a function that will take whatever has been accumulated before, and if the list is empty, whatever has been accumulated before is going to be 0, and whatever the current element is. And then it's going to go and add the current element to the ACC, and this is simply going to be returned. Okay, so now this thing over here, we're going to stick it into a print line because everything is an expression, everything produces something. Okay, then we're going to see that this is actually a sum of 1, 2, 3, 4. Okay, we can replace it with a 1, we can replace this with a times, and then it's going to be a multiplication of all of them. And also look at this function. It looks like it has two parameters. They're all being used only once, and they're used in exactly the same order. This is going to be the first one, and this is going to be the second one. Okay, and therefore we can simply remove this, and we can also join the lines, and it will be written for us like this. Two parameter list. The second one just happens to be a function as well. Okay, so again, we can do this, and we can also do 0, and we can do plus over here, right? So one is the sum, another one is the multiplication, like this, 1 multiplication. Like this. Now, the important part over here was that this a, it was sort of frozen, right? Over here when we created it. And if you sort of think about function programming, about classes, they sort of have like whatever comes in the constructor. These things are like sort of frozen, right? They sort of have some sort of data, right? And then they have a bunch of methods. Like in this particular case, it was returning only one function over here, but a class can have multiple functions. Okay, so if we had something like, let's actually throw this out. Okay, if we had something like class calculator, right, and we're not in Java, we're defining actually a class inside of a method, inside of an object. We actually don't care. We don't need params, we don't need curly braces, we don't need anything. And if this class, if it had a parameter, right, and this is how constructors are done in Scala, you don't need to have like a, you don't need to declare your fields and assign them to zeros first and have a constructor, and then whatever comes in the constructor, assign them to those values. No, it's sort of like, it sort of looks like a curried function. You know, compare it to, I'm actually going to do, which one is better, this one or this one? Well, you can see both. Okay, so this plus a int, it sort of looks very, very similar to this. Okay, and then we're going to have a body of the class. Okay, and by the way, this compiles even without the body. Okay, kind of useless, but it compiles without the body. Now if we have the body, and the body is going to be also the body of the constructor, so we're going to say print line body of the class is executed during construction. By the way, this is exactly what happened with the main method. Remember when we were using like extends app and this entire code was just in the body? This was actually executed during the construction. In fact, for main, there is a special case because the order needs to be changed a little bit, but essentially like the body of the class is being executed during the construction. Okay. So now we're going to go and we're going to have a def over here, add, and it's going to just want the b, right? So it's going to be like this, what used to be just this function, it's going to be add b, okay? And we're going to have an integer over here, we're going to do a plus b because we have access to both of them, okay? Right, so now over here, if we go, first of all, classes create types for us, right? So as a reminder, we can do type c equals calculator, like this, okay, but we're not going to use it. So if we do val c, we actually don't need to specify calculator, we don't need to specify the type, we can just do a new calculator. And by the way, in Scala 3, you're not going to need the new over here. I'm not going to show it to you, not to waste your time. Okay, then we're going to say that a is going to be 1, right? So we're sort of like freezing the a to be 1 if I type correctly, like this. And as you can see, we can already see the body of the class being executed. Let's actually not have this print line and this one as well. Okay, the body of the class is executed during the construction. So we just constructed it and we're seeing this print line. Now the next thing that we're going to do is we're going to call add. Okay, val result equals c dot add, and we're going to say that b equals 2. Look, it's super similar to what we had before, and it doesn't compile because result is already defined, right? So let's do this, right? So we're basically saying you know, like what we had before, right? We froze it. I removed it. Okay, in fact, let's remove all of this. Okay, you see the similarity. Okay, a was specified here, b was specified later. Okay, let's actually print out the result. All right, cool. Now let's add one more because this is a class, so it can have one more. So let's do subtract, and for example over here in subtract we can do a plus b. I'm sorry, a minus b. Okay, so now we can also do well, maybe do this and maybe do that. Okay, like this. First of all, let's talk about object. And an object, think about this. Okay, so this is going to be object. I'm going to call it C, like similar to this one. Okay, if inside of this we're actually going to define a class, and we're going to call it C dollar or something like this. Okay, this is going to be a class. Okay, then we're going to return new C dollar, right? So we're hiding the class, we're creating only one instance, and we're assigning it to this value. Okay, and so we have only one instance, we have a single instance. So what I have written here is very similar to simply saying object C. Okay, So behind the scenes, a synthetic class will be created for us, an instance will be created for us, returned and assigned to C. Okay, and what you can also have is you can have companion objects for classes and traits. So the way you do this is by simply having an object which has exactly the same name as some class. Okay, like this. And because it is in the same compilation unit, which typically means in the same file, you can actually it will actually work, and they can actually access things from each other. Whatever is going to be inside of this companion object, you can think of it as a static method in Java, for example. Okay, so what we're going to have in there is going to be very fascinating. So we're going to have a variable in there which would calculate how many calculators we created, right? So we're going to have calculators created, which is going to be an integer, and the default value is going to be underscore. So if we're inside of a class or an object or a trait, Scala will know that this is an int, and therefore the default value for an int is going to be 0. So behind the scenes, Scala will simply do this for us. Okay. And what we're going to do is, whenever we are creating calculators, right? So instead of printing this out, we're going to say calculator dot, and remember we could also import calculator and this field, and we can just do plus, plus equals whatever whatever was there before, plus equals 1. Okay, and therefore when we're creating it, we can also let's actually not do this. Let's actually just go on print out calculator dot calculators created. Okay, so if I do this, let's do C1, C2, C3, C4, then we're going to see that it has been created four times for us. However, this variable is not super protected, right? From the outside at any point in time, we can go and ruin it, right? We can say calculator dot calculators created equals, I don't know, 1337, and now now it's ruined. Now we have like access modifiers, like for example we can do private, but if it's private, then we're not going to be able to see it from the outside. And we have a thing that will allow you to actually access it. It's sort of like a pattern, and there's a bit of syntactic support for this pattern. Okay, so what you do is you basically have, you call this like with an underscore, so the variable is actually hidden. Okay, and so you also have just a def, and the def is not going to be private, and you actually call it with a proper name. Okay, like this, with a proper name, and it will simply return this variable. Okay, so now at least this code is fine, but this code is not fine, right? So you cannot assign like things to this because it's private. Okay, now because it's private, there's also another fancy thing. So you can define another method which is going to look like a setter in Java, right? So we're going to call it exactly the same. Okay, but in its name, behind at the very end, it's going to have an underscore equals, right? It just has to be like as part of the name. Okay, now we're going to have new value, which is going to be int. It's going to produce a unit, and all it's going to do, it's going to go to this variable, right? This variable, and it's going to assign it the new value. Okay, it's a side effect. Okay, now everything else works out exactly just fine, but now from the outside you cannot go and do this if you make this method private as well. Okay, like this. So now from the outside you cannot go and change it. All right, so again, like this is like magical syntax behind the scenes that will simply call this method, right? It will simply call this method dot, okay, and equals as well, okay, and it will pass in the new value, and the new value is going to be this, this plus 1, right? So instead of this one line, you can also write that like this. Okay, as you can see, there's a 4. Okay, now again, like this highly like mutable code is actually very rarely, well, almost never actually used in Scala. All right, let me actually throw out this companion object. Let me throw this out, and let me show you traits. Okay, so we have this C, and let's also bring back these two guys. Okay, so traits in Scala, they're similar to interfaces, so you can but they can actually have implementation. Okay, so for example, you can have trait add over here, and we're gonna have like this function, we're gonna have it defined over here. Okay, now if you don't have a definition, if you don't have the equal sign, then this method is going to be abstract. Okay, you don't have like the abstract keyword or anything like this. And now over here we can extends add. Okay, and now we don't need to have an override keyword or an override annotation because this method was abstract. However, if it wasn't abstract, and we would have a trait over here which has both subtract and add, right? So it's going to extend add. Okay, so it will have def subtract, which is going to be b int, right? Because it has the add, it can actually call it, right? But just do it add minus b, right? So a plus b is, in subtraction is the same as a plus minus b. Like a minus b is the same as a plus negative b, okay? So if we have this, and now we kind of have a choice. We can mix in both of them. We can say extends add with both of them, or we can just, now it forces us to use this override modifier because we're overriding a method, okay? So we can use like both of them or only one of them. It actually doesn't really matter. Okay, the first time you say extends, after this you say with, okay? And if we're not overriding this, it's still gonna work just fine because we have an implementation over here for subtract, and over here we have an implementation for add. The next thing that I'm going to show you is going to be slightly weird, so don't worry about it if you don't really understand it. So there's a way to not extend add over here and still have access to it. So we can say subtract over here, right? And instead of extending add, right, because we still need to use add somehow, right? So this is going to be subtract, okay? So we still need to use add somehow. However, we can't, like it's nowhere near in scope. And there's a way to go over here and say this colon, and we can say add over here, right? So it basically will force us. It will say over here that we're using subtract, but it doesn't conform to subtract self-type. Subtract was add, so we're being forced to also add, okay? Or over here, extend add with subtract. Okay, so the way this works is basically that you can go over here and you can call it however you want, like you can call it whatever, and you can go and do whatever dot add. Okay, this is just a convention, like usually it's being called self. Okay. And you can also, like, this is a type, right? So you can also do here add with, I don't know, some other trait. Let's call trait blah, right? So you can say with blah, okay? And then over here we're going to be forced to put blah in there as well. Okay, there are a lot of like variations on this. Okay, so we're going to have add with subtract. Let's remove the blah. Let's just do this. Let's just do that. We're not in Python, so we don't need to do self.add like this. In fact, let's actually go back to the original code, which looked very simple. It was a simple class, and it had just add with a b int, and it was doing like a plus b. Okay, and over here we're doing subtract. So let's just do add. Okay, great. Now, what I want to show you is that usually, like in functional programming or in general, like in any kind of programming, like orientation brings this sort of concept of having these classes and then throwing data and methods into the same scope and having them live there in there. However, it's a best practice to actually have classes only as bags of methods, and they should never expose the data. And so in Scala, by default, if you were to try to access actually this A, which is over here, it would actually not work. Okay, so you would have to. So by default, this is actually a private val. So you would actually have to go there if you wanted to access it from the outside. You would actually have to put in a val over here or a var. But you know, nobody does anything weird like this. The issue is that like this is only moderately useful. So for example, like you have a calculator, it has like some frozen A inside of it. Okay, so let's call it C1, for example. Okay, now if you create C2, okay, with exactly the same A, okay, and if you wanted to try to compare them, okay, so if you want to do like C1 equals C2, then you're going to see that it's false, because again, classes are not designed to be used as data structures. So let's actually have a better design for it. Let's actually go over here and define add properly like this. Okay, this is like much better. So now we're going to create a calculator. We're going to call it just C. We don't actually need any parameter list, so we go and we're going to do print line calculator. Let's actually call it calculator and not just C. Calculator dot add A equals 1, B equals 2, like this. Okay, so this is a much better design, and even better design would be to realize that it actually doesn't have any internal state, it doesn't have any mutation, doesn't have anything. So we can just go and do object calculator, and now over here we're just going to use the capital C, and we don't even need to create an instance of this object. Okay, so this is, you know, this is more typical. And also we could kind of have fun, and you can go back to this add design, okay, and just move this guy over there, right, and also have, you know, subtract and move this guy in there as well, you know, subtract, and you can do like A minus B, and now your calculator could simply look like this: extends add with subtract. I know it's a bit weird if you're not used to Scala, but like this object, this class, it doesn't even have a body, but it behaves exactly the same way as before. All right, so it has add and it has subtract. Now, I also want to show you how to get access to this type, right? Because like usually when you have a class calculator, then you have access to the type calculator. However, if you have an object calculator, then you don't see the synthetic class that was generated behind the scenes. Now, usually you never do this because if you want to have access to this type, it means that you want to have a function that works with it. And if you want to have a function that works with it, then you would just put it inside over here. However, in this particular case, let's pretend like we don't want to do this. Let's pretend like I'm going to remove all of these. This is just an object. It doesn't actually have anything, okay? So I'm going to go and I'm going to define the method subtract, okay? So it's going to want the a, the int, and the b, the int. It's a very, very weird design. And we're also going to say that it actually wants a calculator, okay? And the way you get access to this type is by doing dot type over here, right? Because if you just do this, it's going to be a value. It's not going to be a type, okay? So you have a type over here. Whole thing produced an integer by doing just simply, okay, we actually need to have let's do add. Okay, so let's do add def add a int b int produces an int, does a plus b. It's a very, very, very weird design. I'm just showing you how to get access to this type, and that's all. Okay, in my formatter, in my prettier, there's a setting that if a method has 3 arguments or more, then it will be collapsed like this. Okay, but at this point, again, like why bother passing it along? You can just do capital C, and then you don't even need to pass it along. Okay, this was like a lot of weird design. Let's finally talk about data structures, which are very fascinating in Scala. So let's say that we have a class person with a name string and age of int, and we're going to create a p1 with a new person of Bob, and age equals 27. Val p2 is a new person of Bob, and age is going to be 27 as well. Okay, so we're printing out p1, printing out p2, and we're comparing them. p1 equals p2. Okay, so these are regular objects, which is why their toString method looks weird, which is why the equality returns false. Now all of that doesn't sound like data structures. It sounds like objects. Now there is a way in Scala to declare data structures. However, the class keyword is reused for that. Okay, so if we do like a case over here, right, then it's going to become a data structure. The toString is going to look normal. You know, the equality is going to be magically there. You don't need to say new. You can access the stuff inside. You know, p1.name, p1.age. You know, many things. You know, inheritance is unfortunately not disabled because of a very obscure case, so it's a convention to always make them final so that you cannot extend from person. Okay, you can also pattern match on them. For example, we're going to do val, and we're going to have na, and we're going to do p1. Okay, so this is going to be a pattern match, so it's going to like a tuple, but it's like a name. Like, so case classes, they're like named tuples. Okay, so over here we can do printline and printline a, and let's actually do this and do that and do that over here like this. Okay, so as you can see, they're very, very, very convenient. And also, for example, you know, because equality is being checked for you, so you can do something like set of p1, 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 and the set is going to recognize that they're all the same, and so it's going to filter out the duplicates for you. Now you cannot change them; you can only mutate them, and there's a convenience method, right? So you cannot go and do like p1 dot name equals not Bob. Okay. It's going to say that this is a reassignment to a val. You cannot change this. Okay, by the way, in the very, very beginning of the crash course, I actually forgot to show you this compilation error. You just believe me that vals were not reassignable. Okay, however, you can actually do p1.copy. Okay, p1.copy, and we're going to say that age is going to be 33 and the name is going to be Vlad now, which is my age and my name. So this is going to create a completely different person. Okay, so over here we're going to do printline p1 and we're going to printline p3, completely two different people. Now there is also a way to make these guys vars. By the way, notice that they automatically became vals and they were automatically accessible. There's also a way to change them to vars. For example, this is a var. Okay, and now you'll be able to go and say, I don't know, p3.age equals 45, and you would print line p3.age like this. However, there is a problem with this design. Like for example, let's say that let me actually remove all of this stuff. Okay, so let's say that we have p1 equals person. We're going to say Alice is 25 years old, and we're going to do 26 and 27, right? So this is going to be p1, p2, and p3. Okay, so if you create a set of them, right, set p1, p2, p3, and we're going to print out print out this set. In fact, let's actually do s dot for each print line. Let's actually call it set. Let's call it properly set. Okay. Now, if this one is 25, then it's going to be filtered out, right? However, because it's a variable, and at any point in time, you can actually go over here and you can say, okay, p2, age is also 25. Okay. So now you're going to do set for each print line. And now all of a sudden your set is going to contain duplicates. Let's not have this one, right? So now all of a sudden it has this 25 twice, right? So all your code is going to break. So in Scala, we really don't like don't like mutability. Another thing that I should probably mention is that Scala is not JavaScript, in a sense that the statically typed system also ensures that the types cannot change. Okay. Now, for example, like this is a variable, you can change the age, but you cannot change its type. For example, you cannot add a field. In fact, let me actually show this to you. If I go to another virtual desktop and I'm opening my Chrome, which still has the same page open, and I'm just going to go into the console like this. Let's actually maximize it like that. Clear everything. Okay, so in JavaScript you can do something like this: const person equals, and you can say, name is Bob, okay, and age is 25. Okay, and whoops, that was not supposed to be a colon. This was supposed to be a semicolon. Okay, so now you can do console.log person, okay, like this, Bob 25. And now at any point in time, you can go and do person city equals New York. Okay, and it just worked out just fine, right? So you can do console log person, it's just fine. So you changed the type, you added a field to something that already had a type. Like in a statically typed programming language, this would never work. You cannot just go over here and do p3.city equals New York. The compiler is gonna look at you and say like you're silly. It's even gonna say like, did you mean copy? Like, no, I didn't. I didn't mean copy. Okay, so you cannot just go and add stuff to already existing types. Okay, let's actually remove this var. Okay, remove this as well, and remove this as well, and remove this as well, and do it like this. Okay, so for the same reason, you cannot just change the type. So you cannot just go and do, let's actually do this, right? So you cannot say var I equals 25, okay? And then you can go and say, let's print out the I. Over here, sure, you can do I equals 26, because it's a var, but you cannot do I equals hello world, right? It's not going to compile. However, in JavaScript, this is totally fine. Let's actually go there and do this again. I actually close the console. Okay, let's clear it again. So let's do let I equals 25, console.log I. Okay, and later you can do I hello world, right? And console.log I. Okay, in a statically typed programming language, this would never fly. All right, let's go back. The next thing that we're going to see is how to have families of data structures. Okay, so what we're going to do is we're going to have a so-called sealed, either sealed trait or sealed abstract class. The difference between abstract class and a trait are very, very minor. The only difference is that there are two differences. The one is that a class can only extend one abstract class, however, it can extend as many traits as it wants. And the other difference is that abstract classes can have a constructor and the traits cannot. The distinction that is actually gone in Scala 3. So we're going to do a sealed abstract class, and we're going to call it entity. We're going to have a companion object for entity, and inside of it, we're going to do final case class person. It's going to be name, string, and age, and extends entity, right? Same as before. Now we're also going to have, why is actually red? It shouldn't be red. Okay, so now we're going to have case class employee, right? And it's going to have some sort of ID, which is going to be integer, and it's going to have its personal data, person extends entity, and we're also going to have the last one. It's going to be case object on identified. Okay, by the way, this is one thing that I have forgotten to show you. Look at the object main. If you print it out, it's like a regular object. It has a regular weird toString. If you add a case in there, then the toString is going to be it's going to look awesome. This is pretty much the only difference. You can pattern match on objects even if they're not marked as case. All right, so let's go back to this guy. Okay, like this. Let's create a couple of them. So we're going to do, for example, something like valp entity equals entity person. We're going to do name, which is name. We're not in JavaScript. Name Alice, and we're going to say age equals 25, like this. Now we're going to create an entity, which is going to be an entity like this, right? We're going to say entity.employee. Okay, ID equals 1337. Person equals entity.person. We're going to have name equals Bob, and we're going to have the age as age as 28. Okay, let's go and print line P and print line E. Okay, like this. So we have a person, we have an employee. Great. Now, before we continue, I actually want to show you how to do this in Scala 3 because Scala 3 has a better syntax for it. So I'm actually going to copy this. I'm going to go over here and over here, I'm going to paste it over here, right? So that you still see the old one, right? Like this. Okay, so basically the syntax is like this, that you define an enumeration, you call it entity, and then you can use the curly braces, but we're going to use this new syntax like this. And inside of it, you just say case. You don't need to do like final case class. You don't need to extend entity, and just put them all inside, right? Like this. The other case is going to be employee, like this, and the other case is going to be unidentified, like this. Okay, so it's going to behave exactly the same. There's one tiny difference, which is over here. So if I copy these guys and then bring them in, okay, like this and like that, then if you're using this constructor function, then the type for a person is going to be entity, right? But over here, if you look into employee, the employee wants it to be a person. Okay, and there's a workaround basically by not calling the factory function, but to actually call the actual constructor like this. If you really need this, you can do this. Okay. Great. Let's actually go back over here where we have the P and the entity. We're going to have like a simple function. Let's actually do this. Let's do that. Let's go and say should pay salary, and it's going to be an entity, and it's going to produce a Boolean. And the way you deal with them is you pattern match on them. That's the thing about case classes and case objects. You can pattern match on them, right? E-match, and we're going to say, okay, so if it's an employee, then we're going to return true, and in all the other cases, we're simply going to return false, like this. Okay, should pay salary. Okay, so now we can go and do something like print line should pay salary P, should pay salary E, and it's going to be false and then true because the first one was just a person. Okay, now one of these, like Scala has many they're called algebraic data types. Don't worry about the name, or ADTs. And there are many of them in the Scala standard library. For example, a list is an ADT, right? So you can look at it as a family of, or basically as a type, and multiple ways to create this type. For example, a list, there are two ways to create this. It can either be empty, or it can contain one element and all the other elements. Other data structures like this, other ADTs like this that we're going to play with is called option. Okay, so what you can do is you can go and do val option 1, right? The type is going to be option. Okay, and so it has two forms. Okay. The first form is called the sum. It just wants some value, right? So we're going to do print line option 1, and the other one is going to be none, right? So similar to like an empty list. Why did I do this? Int like this. Okay, so it's going to be none like this. So we can print out option 2. Okay, so this one is sum, this one is none. Let's actually have this guy over here like this. All right, great. We have an empty one somewhere, like an unnecessary one. Let's have it over here. Like this. Okay, so this one is a sum, this one is a none. Now the way you work with null is the same way as you work with any other ADT. You just pattern match on it. Okay, so we're going to go and define a method which is similar to this one. So we're going to go over here and we're going to say def add 1 and turn into string. Okay, so it's going to receive some option, which is going to be an option of int. Okay, and we're going to produce an option of string. Okay, like this. And what are we going to do? Well, we're going to do option. Let's create a bit more space. Okay, like this. We're going to do option match. Okay, there are only two forms. There's sum and, okay, I'm going to do sum and n plus 1. Okay, we're going to do toString over here, and if it's none, well, it's going to stay none. Okay, by the way, I believe that this is the first time we're doing something like this, right? I'm not sure. Okay, essentially it sort of looks like the constructor and we're getting access to the value that was inside. Okay, and so now over here, for example, instead of just doing this, we can wrap it in parens like this and actually call this function. Okay, so what it's going to do, it's going to do turn 1237 into 1238 and also convert it to a string, which we don't see over here, but if we were to store this into a variable, we would see that. In fact, maybe actually, let's do this real quick. 1 equals this, and you're going to see that it's a string. Okay, let's revert this and also add it over here, okay? And if it was none, then it would actually stay none, like this. And options are very, very convenient to avoid nulls. In fact, I've seen a couple of Scala crash courses that claim that Scala doesn't even have nulls. We do. It will improve a little bit in Scala 3, but you know, we do. Okay, so let me show you an example where options help to avoid null. So let's say that we have people. I'm going to have list of entity, entity person. So in this particular case, we don't have entities. We specifically have person. Okay, let's do this. Let's have entity dot person. I'm going to have Alice. We're going to have 25, and we're going to have entity dot person. We're going to have Bobby. And we're going to have 26. Let's not forget a comma over here. Okay, so now we can go and we can print line people, oh, come on. People find, and find is like filtered once a predicate, but filter would produce another list, and find will just grab the very first one. I'm going to say, okay, find the person whose name, two lowercase, starts with Bob, okay, like this, and it's going to find Bob. Print line, people find, you know, age, age modulo 2 not equals 0, like this, and it found alias. Okay, but if we try to find like a person which I don't know, starts with a G, then it's going to be a none. Okay, and so this is more type safe because now you cannot just go and start working with this thing because it's not a person. You know, you can only call the methods that are defined on an option, so you cannot forget to unwrap the option. In fact, that's not true. There's actually an unfortunate thing in the Scala API. You can actually call get, and then if it's none, that it would actually throw an exception. Okay, wrong place, not here. All right, right here. Okay, so you call and get, and it throws a no such element exception. Okay, by the way, you can work with options the same way you work with collections. You can think about it as if it was a collection, as if it was a collection with only one element, and I'm going to show you an example in just a couple of seconds. Okay, for now, let's actually throw these guys out. And let's actually define a method called age for our entities. Remember our three entities over here. So the method called age is going to grab the entity and it's going to produce an option of int. Okay, so it's going to do e match, and now we're going to say, okay, so if it's an entity of employee, okay, then we don't care about the name, but we care about the person. So we're going to destructure the person as well. This is a nested pattern match. Okay, it's a deep pattern match. Then we're going to put it into a sum. Okay, so we managed to extract the age. And by the way, because it's a sealed abstract class, we'll actually get a warning that our match is not exhaustive. Okay, so we actually also need to do a case, and we're supposed to actually get, yeah, so we're supposed to get a help. We can do like person, name, age, right? But we don't care about the name. We only care about this thing. It's going to be sum of result, and over here we need to do entity dot person. Actually, maybe, yeah, that's what I thought. Metals injected and import for us. Okay, entity dot unidentified, right? So in this case, we have no way to calculate the age, and so we're doing not. Okay, so what does it say? Okay, so this means that I forgot to put an extend somewhere. Yeah, over here, extends entity. All right, like this. Okay, so now we have age. We're not using it yet, but at least we already have it. So now let's go and use it. So we're going to do print line age of e and print line age of p, and we see 28 and 25, right? So e was 28, p was 25. Great. And let's also add one more. We're going to do entity unidentified, and we're going to see a none over there. Great. Okay, now over here we're also seeing some repetition, right? In both of these cases we're doing exactly the same thing. So there are multiple ways to handle this. So we can also say, for example, if this is a person, then why don't we just call age on that person? Age on that person, right? And it's going to call itself. It's going to end up over here in this case, and it's going to be over here. And again, this is the last thing that is happening. So this is a Scala annotation tailrec function. So as I already mentioned a couple of minutes ago, you can deal with options as if they were collections of only one element. So for example, over here, if we look at this, it starts as an option, it ends as an option, but what is happening inside is being mapped. So imagine like having a list of 1 to 3 and then mapping every element to string. So can we do the same thing with an option? Yes, we can. So instead of this, we can just say option.map, the same as if it was a list, and we would do like +1, for example. right? Or we could do like, I don't know, n arrow to the right, and so that we have like exactly the same code over here, you know, n plus 1, like this. Okay, so I can remove this. Okay, but usually you would do instead of this, you would just do like plus 1 in one function, and then you would map again, and then you would do toString in another function. Okay, like this, and we can throw this out. Okay, it behaves exactly like this. Okay. So for example, now if we go and calculate the age of E, for example, okay, over here we can go and say age of E, which is an option. Let's map it to, you know, plus 1, you know, and let's map it to string, and then for each, you know, do print line, you know, as if it was a collection but only was one element. We can do it was E, we can do it was P, 20, 28, 25. Okay, so the next thing that we're gonna do is, because we can treat it as collections, you know, because it has map and it also has flat map, we can actually do something cool like this: sum of all ages, which is going to be an option of int. Okay, it's going to be equal 4. Okay, we're going to grab the age E, we're going to grab it out of age E. Okay, we're going to age P, I'm going to grab it from age P, and we're going to yield age E plus age P. Okay, and it calculates the age, you know, with the option of ints, right? So we're getting inside of the options, we're adding them together, and this full comprehension and this flat map and map, it brings them all back together into an option. Same as we were doing list flat map, we received a list, now we're doing option flat map, and we're receiving an option. Okay, so now we can calculate the average of the age option of double, and then we're going to go and we're going to do sum of all ages. Then we're going to do map, we're going to map it to double, okay, because it's integers, and then we're going to map it to whatever is in there divided by 2, and now we're going to do sum of all ages. We're going to do for each print line. Again, it's like a list with one element, and we're going to do the same thing for the average. Okay, like this and like this for each print line, and we can see that this is the average age, 26.5. It's 53 divided by the 2 people that we have in there. All right, now we're done with the data structures, we're done with the collections, we're done with the object orientation. The last thing that I'm going to show you is a very controversial feature in Scala, but it is a feature that makes Scala Scala. And this feature is implicits, and we have been using it all over the place, but we haven't seen how it works behind the scenes. So I'm actually going to go and I'm going to remove all of this. Okay, and for this example, we're just going to have final case class Apple. And we're going to have weight in grams, which is an integer, and we're going to have a color, which is going to be just a string. Now we're going to have a similar one. We're going to call it orange, right? It's apples and oranges, right? It's 2 different types, 2 different things, but it's also going to have a weight in grams, but it's not going to have a color. So now let's imagine that we have a function that wants an orange. It really, really wants an orange, and we're going to try to give it an apple, okay, in a couple of seconds. Okay, so let's do this, and let's just print line orange like this. All right, so what we're going to do now is we're going to call this function. Okay, so we're going to go and we're going to call this function. Okay, now it wants an orange, but we're going to give it an apple. Okay, we're going to give it an apple. We're going to say that weight in grams is 300, and the color is going to be red. Now obviously it's not going to compile, right? It's going to say, hey, you're giving us an apple, but I wanted an orange. Okay, now if we had a function, right, we're going to call it apple can be used as orange, right? It will take an apple and we'll produce an orange, right? How would it do it? Well, it would just create a new orange, and we'll just take the weight in grams from the apple. It would lose the color because oranges don't have color. They're always orange. Okay. Now, assuming that we had this function, then we could simply call it over here, right? Apple can be used as orange, right? And this whole thing would be a parameter, right? Not really a big deal. It's just a function call. Okay. And by the way, we should probably remove these guys. We don't need them, like this. Okay. This is an orange. Okay. Now, if we remove this function call again, right, then it's still not going to compile. It says found apple, but I required an orange. Now, the compiler, when it fails, before completely failing and showing you the error, it actually goes to certain places, and it looks for functions like this. It looks for a way to convert an apple to an orange, and if it finds one, then it will do it. Right now it doesn't find it because it's not. If it was to go and search through the entire code base, through all of your dependencies, through all of your libraries for these methods, it would never find them. So you need to explicitly mark your functions as implicit, and now it's going to find it, and now it's going to do it for you, right? So behind the scenes, it literally just called this function. It found it, and it ended it. Now it only does this when it doesn't compile, right? Only if it doesn't compile, then it's trying to weasel its way out of this. All right. Now, this particular version of implicits is genuinely, generally frowned upon because you don't see this conversion. You see this is a function that wants an orange. You're giving it an apple. How the hell does this work? Okay. Big IDEs like IntelliJ IDEA that they might actually even show you that there was an implicit used over here. So these conversions, they're called implicit conversions, and they're also called implicit implicits. They're very dangerous, but they're also very, very useful. For example, every time we did something like this, see, this is a character, but we did a 65, an integer is being converted into a character, right? So print line C, okay? Same thing over here. S is a sequence of characters. And on the right-hand side, we're doing a hello world. A string is being converted into a sequence of characters, right? Print line S, okay? Now, similar things are happening when we're doing, I don't know, val b equals byte, and we're doing 25, right? So technically this literal is for integers, but it's being converted into a byte. Val I is int b, okay? Again, like byte is being converted into an integer, right? These are called type widenings, okay? All of these cases. I also haven't showed you haven't shown you the big integers, but the Java API has big ints and big decimals, right? So you can do like big int equals 37, and integer is being cast into big integer. So now you can do big plus 1, and now you can also do print line 1 plus big. Now this one plus big, it actually works slightly differently. Okay, so over here we're calling plus on a big integer, and it just overloaded and it wants an integer. Now over here it doesn't convert an integer to a big int just so that it can call plus. It does it slightly differently. I'm going to show you how this works, and it's this one is called extension methods. Okay, so the integer is being extended with a method called plus that actually can receive a big integer. So let's move these guys out like this. So let's say that over here we have a function that goes from an apple straight to an orange. Let's say that we have a function that would convert an apple into something else, and that something else had a method that would know how to convert it into an orange. Okay, so I'm actually going to comment this one. Yeah, I'm actually going to comment this one. No, I'm going to leave it for now. Okay, so let's say that we had an implicit def, and I'm going to call it with a capital letter. I'm going to show you why in just a second. So we're going to call it apple wrapper. It's just going to get an apple and produce an apple wrapper. Okay, it's going to do a new apple wrapper of apple. Okay, and the apple wrapper is just going to be a simple class. Okay, it's just going to be a final class, apple wrapper. It wants an apple. Okay, and it has a function toOrange, right, which produces an orange. Now the implementation is going to be exactly the same as before, like this one. Okay, because we have a function that can do this. Now over here, this means that we can go and do toOrange on an apple as if apple actually had a function like this. Okay, what is happening? Oh, I called it toRange. Why did I call it toRange? Okay, so now we extended apple with a function, right? But behind the scenes, like what the compiler did is it basically just called this function for us, right? Apple wrapper, apple wrapper, passed in the apple, right? So apple wrapper came out, and apple wrapper obviously has a method toOrange, right? So it's very, very similar to what happened before. In fact, this is such a common pattern that Scala came up with the ability to mark the classes as implicit. Like this. Hold on, let me actually remove the apple wrapper first, like the call to it, like this. All right, and by the way, like these ones are called explicit implicits because at least you see, okay, apple doesn't have a method called orange. Okay, so at least you know, okay, there is an extension conversion to something, some wrapper that actually has a method called toOrange. Okay, now this is kind of a lot to type, so we can actually go and put implicit over here. Okay. By the way, the order of these keywords is not strict. You can do whatever you want. However, in my formatter, I configured it to sort them like this. Okay. Now, what's happening over here is that behind the scenes it would generate exactly the same method. So if I comment it out, then it will work exactly the same way. Okay. This is also why I called it exactly like this. Right. This method is still there. You just don't see it. It's being generated by the compiler. Okay. So this method over here is still there, even though it's commented out. Okay. Now, common convention is let me actually move it out to an object like this. Okay. A common convention is, okay, I need to move these guys out as well, like that. Okay. Is to also extend any val right? Remember I told you that any val is like an optimization, because like every time over here you're doing to orange, it will actually create another object of apple wrapper just so that it can call a method. Okay, so if you do this, then it's gonna use like a table at compile time instead of actually creating objects at runtime. Okay, so if you just do extend any val, however, any val is a bit constrained, it will force us to have a val over here, and we can also make it a private, and it's also a convention to call this one self, and self, like this. There we go. All right, so we have now implicit implicits and explicit implicits. Now, the explicit implicits are actually used all over the place. This is exactly how we were able all the time to do things like this. Okay, print line, 0 to 10, right? This is a regular integer. It should not have a method called 2, but somewhere there is a wrapper, that converts this integer into something into this wrapper, and this wrapper has the method called 2. Same thing for the tuples. Same thing, even for this thing, this is a regular Java lang string. Okay, so if you do val s equals, and we're going to do this, then the type of s is a string. It's a Java lang string actually, right? So Java lang strings, they don't have a method called times, right? They just don't, right? However, Scala has a thing that converts it into something that actually does have that. Okay. It's also the same as we were doing, remember this, Java util hash stat, and we were doing as Scala. However, it only worked if we imported, what was it, JDK, I don't remember, Scala.jdk, doesn't matter. Okay, in any case, it was this one. And also, if you look at our tests that I haven't shown you, we're using this in the test as well. You should be able right now, by the way, to read this entire thing. You understand packages, classes, I'm sorry, whoops, no, don't run it. Classes, it is final, it extends test suite. Test suite is a trait that mixes in a bunch of other traits. It has a couple of imports over here. It has type aliases. It has some name forwarders, right? You're just seeing val arbitrary is the same as an object that is called arbitrary inside of there, right? So it brings in a bunch of these things into the example suite. Therefore, we can call a function test. It is a current function. It has one parameter, one parameter list which wants only the name of the test. It has another parameter list which wants a function. In fact, like this particular one, I haven't shown you because it would be too long. But in any case, this should be function. Again, it comes from something that is defined in there, some implicit conversion that converts a one into some wrapper that has the method should be. Okay. So we have been using it all over the place. In fact, let's actually define one that is a little bit more intuitive. Okay, so let's remove all of this. And by the way, let's also switch to using extends app. Okay, because now we're smart. We're understanding everything. So let's just remove all of that. Let's just do this and this. Okay, right. So let's go and actually define and final implicit class. We're going to call it any, and it's a convention to call it ops, these are like operations on any type, and we're going to do private val self, which is going to be any. It's going to extend any val. We're going to have a method called styled. Okay, now this method is going to be not super type safe. We're going to be able to pass in any style, but it's actually going to be any string, right? And it's going to produce a string. Okay, so we're going to do style plus self plus console dot reset. We're going to have a couple more. We're going to have red string is going to be styled in console.red. We're going to do this. We're going to do a red, green, blue, and we're going to do a red, green, and blue. Okay, right. And now we can grab absolutely anything we want, like for example a list of 1, 2, 3, and we can just go do red. Okay, there we go, like this. It's called styled like this. There we go. It is now in red. So we have red, green, we have blue, we have styled in console dot magenta. However, this DSL is not super type safe, right? So you can just pass it in some arbitrary string, right? Not type safe space, and we're going to say not type safe 1, 2, 3. Now, I also want to show you the same syntax in Scala 3, because in Scala 3 this is actually a little bit improved. Oh my god, what do we have here? Let's remove this guy. Okay, let's paste it in. Oh, one other thing that I forgot to show you, because the implicit classes, they generate a function, a def. Remember, in Scala 2, defs cannot live outside. So if you put this implicit class over here, even though it's a class, it's not going to compile. Okay. However, in Scala 3, this is not the issue. Okay, so I can actually move it out. And by the way, notice that Scala 3 understands implicit classes as well, right? It just has a better syntax for it. Okay, so instead of like this whole line, we're just simply going to say that this is going to be an extension on any, right? So this entire line just turned into this line. Okay, the rest stayed exactly the same. Okay, well, extension, and there we go. Okay, and therefore I can go and I can get these guys, bring them in like this, and there we go, behaves exactly the same as before. Now I have a video that covers implicits in depth, but as of right now I believe we have covered enough ground. Whoa, what a ride. I recorded the whole thing in one take. It took me like 5 hours. In fact, at some point my camera started overheating, so I had a tiny break. All right. Now, no language can be covered in a crash course, especially another language like Scala. However, I hope that I actually covered a lot of stuff. Now, if you're interested in learning Scala, I need to give you like sort of a warning. Scala is not a broad language, meaning it doesn't have like many keywords, many features, and so you cannot just go and like learn all the features and now you know the entire language. Scala is a very deep language, meaning it has like a small subset of features, but you can combine them in seemingly infinite ways. And therefore, if your approach is going to be to I don't know, to watch a couple of videos or to read a couple of blogs, you know, because you have like this mental block that tells you, okay, I'm not going to write anything useful until I actually know the entire language, it will take you years. So you're not like me. You don't need to teach it. You don't need to know every little corner of the language. So create a toy project and get your hands dirty. And if you hit a wall, Google is your friend, and I also have a Discord server, which I'm sure that you can manage to find on your own. A quick word about Scala 3. I made sure to show you only a couple of really teeny tiny syntactical improvements. However, I haven't showed you so many things from Scala 3, even from Scala 2. Scala 3 is going to come with a lot of really impressive new features and improvements. You know, there are better null constraints, there are better equality constraints. Scala 3 is way more beginner friendly. Really, there couldn't be a better time to get into Scala, and there couldn't be a better time to create this crash course. Brad, thanks again for the opportunity, brother. I hope you guys enjoyed the video. Don't forget to give it a like if you actually did like it. I hope you did. And don't forget to subscribe to both Traversing Media and Dev Inside You. And most importantly, take care.